Well, good evening everybody. How's it going? Hope you're having a super Friday evening. Who have we got in the chat this evening? We've got Toto Rico and a party of 54. Amazing. Thanks very much, Toto, and thanks for the stream earlier today. It was really interesting to see the work in progress on the Challenger. Yearning9, good to see you. Sam Patch, awesome. Vinny the Great, hey, how's it going? Pancake King, staying out of trouble, I hope. Sneaky Danish, thanks for joining. Rossalo, awesome stuff. Winston, sweet, good to see you. Hope you're looking forward to the Tupolev here. Good old-fashioned Russian goodness, Toto. Well, we'll see how it goes. We'll see how it goes. Smooglarn, awesome, good to see you. Amy, hope you're having a super day. Great to see the progress you've been making on the systems as well. Who else have we got? Captain Crash, great to see you again. Miles, is it Miles Mace 1? Great to see you, first time in the stream. And Aster, thanks for joining. We've got Airfighter, hey, how's it going? Hope you're doing well. Hope the work on the DC3 is progressing apace as well. And Pilsnerish, yeah, awesome, good to see you. Shoma Boy, thanks for joining as well. And MSA, wow, we've got a lot of people in the chat this evening. Well, I can't promise anything super exciting with the Tupolev. It's been a long time since I flew this aircraft in the sim. Let me just turn the volume up. I'll try and find the right balance between the volume here. We've got the external power unit running at the moment, and we're at Budapest in Hungary flying this Malev coloured aircraft. Captain Crash, I will do my very best with it, but we can't really guarantee anything, I'm afraid. It's a tricky aircraft to fly. It would be a tricky aircraft for a full crew to fly. And we're going to try and use the NVU navigation and VOR stuff as well. I really like this aircraft. I've had it for about 4.5 years now. It's super fun. It's not the most efficient on the system. It makes quite a heavy demand on the system. And it's an old school aircraft. You've got to get involved in flying it. But it's really enjoyable and it's satisfying when it all works out. The NVU, yours, thanks for joining the stream. The NVU it's complicated initially, for sure, understanding what it does. But it's just another method of navigating cross country. And once you've done it a few times, it becomes straightforward. Winston, you're on stand 37. I'm on 31. I'm not on VATSIM this evening. I thought about it, and then I thought that's maybe one step too far with this aircraft. It's a really nice looking model. I love the look of the 154. It looks muscular. It's like a 727 that's been to the gym a lot. The gear fairings look awesome on it. The engines look awesome on it. And this is the M model, although the livery is for a B2 model. Yeah, it just barely fits, Toto. It just barely fits. But I wanted to be somewhere close to the runway. Didn't want to have to do anything too involving. So before we jump inside the aircraft, we need to load it up. It's got this menu system here. And remember, this was designed for X-Plane 10. It's probably 5 or 6 years old, the aircraft. So the menus are not perhaps as slick as you'd expect to see on a current generation aircraft, but it still does the job. You're skipping VATSIM too, yeah, good job. Yeah, VOR to VOR on VATSIM, I don't know, it'll probably work. Let's look at the load sheet first of all. So what we're going to do is, I'm going to move the view around so that light stand isn't in the way of the aircraft here. So first of all, we've got to put passengers on it. So I'm just going to fill it up with 100% passengers. Okay, it's not the most efficient thing in the world anyway, so I want it to be full. We also need to put some fuel on it. It's got this fuel calculator built in. It's all metric. It's in kilometers per hour, kilometers and meters for the altitude. That being said, we've got this NVU calculator that produces a PDF output of an NVU flight plan. It gives you the distance in kilometers, it gives you the fork, which we'll talk about later, and it gives you all these figures, which, don't worry about it, we'll get to those. If you are a SIVA INS navigator, it also gives you lat-lons in the decimal minutes format, which is really fairly useful. And it's actually fairly good for building VOR to VOR flight plans as well. But most importantly at the moment, it's 1500 kilometers. So let's put that in here. I don't like messing around with fuel, so let's leave 500 kilometers for the alternate, that would take us from Heathrow to, I don't know, Manchester, probably just about Glasgow. We'll cruise up at 380, diversion at 320, so that's calculating around about 14 tonnes as the total fuel for the trip. So I want to have 5%, so that's about 700 on top. And I also want to have about a minimum of half an hour at the destination. It burns roughly 5 tonnes an hour, so I'm going to put another 2.5 tonnes on there. We'll take that up to 3.2 tonnes. So if I scroll up to 3.2-ish, that's going to say we want just over 17 tonnes. Let's load that. It's a real beast, this aircraft yearning, isn't it? I think the flight control automation on it, when it works really well. But they've had some issues with the flight controls on these aircraft over the years. It's fairly complicated for what it does. What we need to do is to adjust the cargo hold load to balance it out as well. These are your trims, the zero fuel, forward CG for takeoff, center CG, and for landing forward CG. That's okay, we can use a forward CG, but what we can't have is an aft CG when we're landing. I'm going to put the baggage in the rear hold. If I nudge it up to about 1.5 tonnes, you can see we've got center CG for takeoff and landing. Bread Live, thanks for joining the stream. Yeah, I did some tutorial videos for this back in 2017. And let me just load the fuel before I forget, and we'll load the payload as well. Let me just double check that actually did take there. Yeah, we're all good. I did some tutorial videos for it. At the time, it wasn't getting a lot of views. And I don't make videos for the view count, I make videos that I want to make. That being said, making videos that nobody's really going to watch is a little bit pointless. So I did a systems video on the electrics, and it was my intention to come back to the compass system and the nav system, but really it was getting single-digit views every week, so there was really not much point continuing with it. But on the stream, the longer format on the stream gives us the chance to look at the compass systems and the navigation in a bit more detail. Yeah, it's a Tupolev Tu-154M Cert Eleros, I think it is. Fuel efficiency is a capitalist invention. Hey, it's got to be fuel efficient, it's just it's got to be 70s fuel efficient. But it just looks muscular to me, I think it looks awesome. Anyway, let's get it all fired up. We've got a flight engineer panel, okay? And before you look at all of this and go, I can't work it, I'm giving up. First things, it's in English, we can set it to English. The Russian system uses a lot of acronyms. They'll give things their real name, so you know, they'll use the model number. For example, the PTS 250 inverter here, rather than simply saying the inverter. That gets a bit confusing, but you get used to it. And it's got the same systems that a modern Western-built aircraft would have. It's just the fact they're all exposed to you. You've got direct control over them, rather than having it done automatically. Wide landing gear, it's brilliant. It's built for soft fields and unimproved airstrips. Sand patch, it's fairly good for that. So we've got the external power connected up, but we've not got it switched on. Before we connect it to the aircraft, or before we switch it on to the aircraft, we're going to put the batteries on here. We've got 4 batteries. Now watch the lights as I put these batteries on. You've got battery 1 and battery 3 on one side of the aircraft, and battery 2 and battery 4 running the other systems. With the batteries on, I can click the external power to on, so GPU here. Note how it says external power on the voltage selector and GPU on the current selector. And these dials here only control what appears on the gauges. They don't do anything with what actually happens on the aircraft. So external power comes in, and we'll see the GPU current picks up a little bit. So we've got AC power coming in from the external supply. We've got the batteries on, so I need to put the rectifiers on, and that converts that AC into DC to keep the battery system charged. And we can see that on the gauges here. If I look at my battery voltage on this bus here, if I switch the rectifier off, it's actually the right one I want, there we go, it goes down to, what, 25 volts, 24 volts for the battery. But as I bring the rectifier on, it jumps up a little bit, and that's how the batteries are charged. So we've got an aircraft that is being powered by AC power, and DC batteries are on. Beside the first officer over here, we've got the nav lights, we've got the beacon lights and the tail logo lights. And it's lit up. It's also got these little interesting ground strobes here, which are a Tu-154 oddity. Hey the Mattium, good to see you. The little ground strobes are switched on up here, ground wing lights. We can switch those off if we don't need them. And whilst we're here, we'll switch on the flight data recorder and the clock as well. I'll switch on the fire protection systems before I forget about it. But we've got AC power established to the aircraft and DC power. But nothing's really come to life. It's just not, it's not really doing anything. We've got flashing lights in English, it's a good thing. But there's nothing really we can do with it. Because rather than having an avionics master switch, we've got all these switches up here. Now, before I click these switches, if you're familiar with the 154, there's a set sequence you've got to do all this stuff in. There's only some things you can put on before you start the engines. For the model, it doesn't matter, okay? And this video is really about learning the navigation stuff, so I'm just going to switch everything on. It's as easy as switching almost everything on. I'll leave the test switch here open, and I'll leave the autopilot flight directors open. Other than that, everything can come on. Okay? There's only a few switches we need to worry about when we're operating this aircraft. Everything comes on. The radals, VHF radios, HF radios, DME. We can check the pitot heat just now and make sure it stays in the off position. Windshield heat goes off as well. We're going to minimise the drain on that ground power unit. On here, Doppler nav, that is what we're interested in. I want to make sure it's powered off, but I'll tell it we're over the ground, not over the sea, and I want to enable Doppler navigation. I want the seatbelt signs, the no smoking signs, and the exit signs on. Intercom will switch it up to VOR if we're going to ident any radio aids, and that's the overhead done, so it's looking a lot more healthy now. We've got the GNS 430 down here. We're not going to use the GNS on this flight. Yeah, Winston, it's exactly the same. Even the LEP 410 for X-Plane, you've got switches. You have to switch switches on for everything, rather than just a single on-off switch. You'll notice down here we've got 1 altimeter, 2 altimeters, 3 altimeters. This one's in conventional units with hectopascals. This one's in inches, millimeters of mercury. And this one you can switch to feet or meters, but it uses millibars or hectopascals. So we want them both to be yellow because pretty much everywhere is now flying on feet. Yeah, 50% switches, Vinny. 50% switches, and the other 50% is flight control surfaces. The yokes on these things are huge. The flight, if you look at a LEP 410, the yokes on it are massive. Right, so where are we now? We need to make sure that the ground is ready to go. So we've still got the chocks in at the moment. And I'm going to be extra careful with the parking brake, both before and after landing today. Parking brakes are going to be important, so feel free to shout at me in the chat for parking brakes. We've got hydraulic systems here. Hydraulic systems 1, 2 and 3 and the emergency brake accumulator. We can check the levels in the hydraulic systems. I don't really worry about checks on this aircraft. What I want to do is to pressurise the hydraulic systems. So we've got an electric pump for system 3, and that's going to put the pressure into this one. And it has quite an impact on the current. Look at the current up here as I put the second one on. Okay, so we can run both together, but not when the fuel pumps are on. Okay, we don't want to run the fuel pumps and the hydraulic pumps together. That's pressurising system 2 and system 3. I need to pressurise 1 and the emergency brake as well. So I'm going to couple system 2 and system 1 together, and I'm also going to hold the accumulator, and that is now running pressurising 3 systems off that 1 pump. So I've got to hold this button down, and it takes a little bit to pressurise the systems. Now again, these systems aren't old-fashioned on the aircraft. It's got the same, roughly the same systems as a modern aircraft. It's just all exposed to you, it's all mechanical. Electromechanical systems rather than electronics for the most part. So, all of the hydraulics are pressurised. I'll take the pumps off. We'll go outside, and do you know what? Why don't we get rid of everything I'm likely to forget later? So I'm not going to touch the ground power unit, we still need that. I can close the cargo door, the kitchen door, get rid of the catering, the fuel tanker, and take the gear blocks off and the passenger doors. So it's just that ground power to go. Now at this point we'd start the APU typically, but I don't want to confuse the navigation and the engine stuff, because really we want to focus on the navigation equipment today. First things first, we're going to align the compass system, and this is where people can come unstuck with this aircraft. I need the overhead panel to do this, and I'll catch up with your chat in just a second. If I fall out of my flow on this, I forget how to drive airplanes. So I'm going to use this switch down here, this panel down here. It's just the overhead. So this is our main HSI, this is our directional gyro indication, and this is our RMI. With the main HSI, I can switch it between gyro mode and magnetic mode. Okay, and we can do that on the right side for the FO as well. But what I need to do is to align my compass system here to magnetic north. It's currently applying magnetic corrections to the RMI. It's keeping this magnetically aligned even when the main gyro isn't quite there. So what I need to do is to set the latitude corrector. So we are at Budapest, which is 47 north. You know, we're nearly there just now. I'll switch it to mag mode here, the main gyro, which is this needle here, and I'm just going to push the adjustment button. And as it rotates, this moves and this moves, because this HSI is looking at the DG mode just now. Okay, you see it rotate round, and then it lines up on 040, which is where we are. Now for my reference gyro, that's the little index on the outside, that'll move the FO's side. If I move it slowly just now, you should be able to see it move both ways. But I can also adjust it. You see the index moves. It's only got a little bit to go, but as I move it, watch the RMI move as well. Okay, the reason that happens is because the RMIs are swapped between one side and the other. So this is your number 1 compass system and your number 2 compass system right there, and the FO's got the opposite. That can be a little bit confusing. Okay, but that's how it is. The magnetic system is different from what you have on a Western aircraft. Firstly, they don't really seem to trust the magnetic system. You've got corrector blocks in here. This is where it's sensing the magnetic information. But also, it's sitting on top of these gyros effectively. So as I rotate the main gyros, it will remove the alignment from the RMI. So I simply have to go back to DG mode here and push the adjustment button. You see how it's moving very slowly. If I push and hold, it moves quickly. And it's the same over on the FO side here. Okay, they were all pretty much in alignment. We've got 2 gyros pointing the correct direction. We've got 2 RMIs properly aligned to magnetic. The switch is in the middle, so both gyros will be both magnetic systems will be continually aligned to magnetic. And we've got the gyros here, and because they're aligned, switching between DG and mag, it doesn't make any difference, it stays pointing the same direction. So that's the compass system. Remember that the RMI scale, if you like, sits on top of this needle here. So when you move this needle, you move the RMI as well. It will correct itself over time, but you just need to be aware that it changes. When it's in this mode here, the directional gyro, when you're flying it, it won't correct to magnetic. It's not like an American or a British or a French aircraft. It doesn't correct the main gyro to magnetic as it flies. Now the reason it doesn't do that is because it's designed to let you fly great circle tracks using just the gyro. And that's something that conventional aircraft can't do without an inertial navigation system. This can fly great circle tracks, whereas a 727 can't unless it's using an inertial navigator. Right, so the compass system is all aligned. We've got to get ourselves out of here and flying. I'm not going to fly a complicated departure because I don't think that's relevant for what we're going to do today. I don't want to make it too confusing. we're simply going to fly from the Budapest airport towards Golf Yankee Romeo, which is just out towards the west here. With this flight plan format, we are looking at, to get from, for example, Budapest to Golf Yankee Romeo, we read this line here. Okay. So what we're going to do is firstly put it onto the VOR system here. I want to navigate to Golf Yankee Romeo 115.1. Let's put it up here, 115.1. And because I like to keep it simple, let's put it on both sides to be the same, 115.1. I'm going to leave it set to kilometers. DME VOR set, and I can't remember what you're supposed to do with auto and manual. Don't remember what that does, but it doesn't seem to cause an issue. 115.1. The course from Budapest to Golf Yankee Romeo, we can read the magnetic course in here. It is 276.9 or 277. And here's another case where the Russian design is a little bit different. I need to set 277. We'd normally set 277 on here. Okay, we can set 277, it's kind of hidden behind the little line just now. But we've also got to set it down here, 277. So this is where it reads the deviation from. This is what drives the pointer bar, the little deviation bar here. But the autopilot uses this value here to steer with. So it can get confusing. If you've set one and not the other, you're not going to get predictable results. Okay? Having said that, this is sounding quite complicated already. When you see it fly, it actually works quite well. We could basically start the engines and go flying now and navigate VOR to VOR. We've got the list of VORs, we've got the initial magnetic track off the VORs. This is enough to go fly. But I want to use the NVU system as well, the Autonomous Navigator. So it's kind of like an INS, but it's not really an INS. It's more of a dead reckoning navigator with Doppler correction. Now, Doppler correction is a little radar on the bottom of the aircraft that looks at the ground, looks at the drift angle, looks at the speed, and feeds it into the system. Lots of older aircraft use Doppler navigators. It's down here, and again, wow, this looks complicated, huh? It's not that difficult. I'm going to power it up first of all. I'm going to put the corrections on. I'm going to leave calculation switched off, and I'm going to bring up my flight plan. And we want to get from Bravo Uniform Delta to Golf Yankee Romeo. So I'm going to put it up here. You can see we've got this MPU V value and the S value. That's all we need at the moment. Corrections on, yep, feed corrections into system, sound patch. I think you can do it when you're airborne, but I tend to forget, so I always leave it switched on. We want to put this 276.9 in and this 116.8. Let's do the first one, 276.9. It's up here, this is your course that you're going to fly. Fast mode and slow mode. So fast mode, 276.9. 276, here's your first challenge, 276.9. 276.9 in minutes, that's 276.54. Okay, so when this device comes to life, it's going to fly this track. It's very similar, in fact, to the magnetic course, because as you start off, this is aligned to the local magnetic at Budapest. It'll change as we get further down the track. I don't use RSBN sound patch, so I don't know much about that. 275 degrees 54 minutes. What's that, Captain Crash? 276. Yes, 276 degrees 54, 276.19. We also need to tell it how far away Golf Yankee Romeo is. Now this says 116.8. That's from Budapest to Golf Yankee Romeo. I'm not going to fly overhead the Budapest VOR. I'm going to switch this system on once we're airborne. So rather than setting 116.8, I'm simply going to set 50 kilometers and we'll switch the system on at 50 kilometers from Golf Yankee Romeo. So I put this little switch here to S, and it's going to adjust the value up here. You see, this is my distance to go. Again, fast mode and slow mode. I'm just going to wind it to the left, until I get to 50 kilometers. Okay, so there's 50 kilometers on that course there. It only has the 2 windows here, and when it gets to this point, when it gets to Golf Yankee Romeo, it'll swap from system 1 to system 2. So I can load that as well at this point. The next track I need is 297.7, so let's put it on the system that's not in use at the moment. 297, nearly there, decimal 7, there's decimal, so that's decimal 5, decimal 6, decimal 7. 297.7, and our distance on this one is 95.5. So rather than setting the S value, I'm going to set the SP value. This one's eliminated as point, so it's SP, and we wind that back to 95.5. And again, if you're not keeping up with this at the moment, A, I don't blame you, B, it took me ages to learn how to do this, and C, when we get airborne and it all works, it kind of makes sense. But this is it set up and ready to go. The only other thing we need to do is to turn on turn anticipation. If I set it to 5 kilometers, with 5 kilometers to go, it will switch from system 1 to system 2. So we just check this figure here, we check this figure here, and this figure here, and then we're ready to go. And that's pretty much it set up. Okay, that's it ready to navigate for us. Correction mode is to align the RSBN to the NVU. With that you can... Okay. Are you sure it's not calc? No, I don't want calc on just now, Sandpatch, because that'll have it counting from the runway. What I want to do is to get the wind corrections into the system. So the corrections also feeds the wind corrections into the aircraft, I believe. Again, I've never used it with RSBN, so you could be right, but wind corrections is above. Which one's that? Oh, is this the one up here? This one here? Ah, okay. Well, to be honest, I know this works at the moment, so I'll run it this way and then we can have a look at that later when we're airborne. NVU by DOP, okay, gotcha. So what we need to do is to fire up the engines now. Fire up the APU first of all. So, firstly, I want to make sure that my current drain on the GPU isn't too high. It's around about 60, 70 amps there, it's fine. We'll switch on the APU start switches here.
Ground, starting APU.
We'll wait for Felis.
APU doors are open, starting area is clear.
And then we'll just start up the APU. Now watch the current on the GPU. Look at the fact that it's connected all 3 of the rectifiers on to provide enough DC current to start the APU. But it's only a momentary load. Once it finishes starting, you'll see the standby rectifiers go offline. It's got 3 rectifiers, the number 1, the number 2 and the standby. Although there's 2 lights, it's the same standby shared between both systems. Hey Tubaflight, good to see you. So, it is now spinning. We've got the APU turning at the normal speed. We need to connect it up to the bus, the generator up to the bus first. So my GPU at the moment is providing, what's that, about 80 amps. My APU is doing nothing. So, as I put the APU online, the GPU load drops all the way down, APU load comes up a little bit, so they're doing about 40 amps together. So they've basically split the buses. The GPU is running some of the systems, the APU is running other parts of the systems. We can now take the external power off and the APU load increases, so the APU is running everything. So with that we can take the ground power out. And we are now running on internal APU electrical energy. So if it was any other normal aircraft, once you turn the APU on, you would turn the bleed on as well. You do that on an Airbus. So you do that on a Tupolev. We'll put the bleed system on here and I'll hold it on. Yeah, it's interesting, Airfighter, isn't it? But the engineers knew what they were doing, and it's not that difficult. Once that light goes off, we've got APU bleeds supplied. I can come over here. I'll switch on the flow regulators, and I shall increase the airflow. This is basically the pack flow valves. Again, you've got these on all aircraft, just we're opening them manually, and we're getting airflow. And we've got APU bleed and APU elect established. Is there anything else that we would normally do on a Western aircraft before we push back off the stand? We'd put the fuel pumps on. So we've got the low pressure valves here. We need to open those and latch them. I'm going to put the fuel equalizer, the automation, the fuel management, flow meter and the quantity indicators on. Okay, so what we've got is 4 fuel tanks and a fuel flow meter, and this is the one that a lot of people forget. You've got to make sure you get this as well. Each of these tanks has got a high test and a low test, so you can check that the needle moves. Okay. The same with tank number 1 up here, but it's also got a combined needle. So that's showing me 3.3 tons in tank 1 and 17 tons in the combined tanks. This is the flow meter, and I have to set this as well. Okay, so I'm going to set this to 17 tons. Now this is exactly the same as what you do in the TBM when you set the fuel in there. When you load the fuel, you measure the tanks and you meter fuel going into the engines. And if there's a discrepancy, if this value becomes lower than that value, then the fuel is leaking out the tanks but not going into the engines. Hang on, let me just fix auto mod there. So you've got to make sure you've got the fuel totalizer set as well. We'll put the pumps on for the service tanks. With the fuel automation switched on, it's choosing the tanks automatically. We'll put the pumps on and we're good to go. The throttles on the engineer's side, well, these are throttles. The engineer's allowed to control the throttles, and these are the fuel cut-offs. So these are the little levers under the throttle on the 737. It's ready to start, I think. Oh, we've got to turn on the engine instruments as well. With that in mind, let's turn on the beacon. Let's turn on the transponder. We got a glitch, there we go. Transponder goes to alt. And let's push back. It's in here. Start pushback.
Ground to cockpit. Please show me where you want to go.
Ah, it was tie when I pushed back earlier today.
Ground to cockpit. Tow is driving up.
Excellent. Oh, just power back. Yeah, we could do that. I'd need to start the engines first. What was that, Toto? Power back, push back first? Yeah, we'll start the engines on the push. Check the panel here. What have we got? We've got the warning there. We've got the boosters. Systems tied. Yeah, that's fine. Excellent. Here comes the tug. We've got the Goldhofer again. If you've got this aircraft and it's not pushing, it won't push you. It's this switch here. I'll look at that on a taxi out, but make sure that switch is forward. Yeah, you might get stuck. You might do.
Okay, all doors and hatches are closed. Ready to connect.
Going to be extra careful on the parking brake here. Can't have another parking brake runaway. Would never live it down. Oh yeah, it was Ty that pushed me back earlier today, Sam Patch, and he's really funny on Better Pushback. I mean, really, it's like, okay, light him up. I'll try not to. Anyway, awesome stuff. It just I love the look of the Tu-154. It just looks mean and muscular.
Tow connected and bypass pin inserted. Release parking brake.
Alright, brakes off.
Starting pushback. And you may start engines.
Oh, it should recognise when the window's open. Yeah, you depressurise at the window, don't you? Right, we're going to start the engine, so we'll keep an eye on what's happening out the front. I'll open the cover here. I shall switch the main switch to on. Now watch the airflow valves here. of the airflow meters. So it shuts the pack flow valves automatically. Switch to number 1.
Doors and hatches are closed. Grounding, cups and tail rod removed. Ready for start.
Excellent. So it's got voiceovers. And with that, we will simply push the start button here.
Clear the engines. Start
Number 1
engine
comes
1.
up. We're looking for the rotation to spring into
Starting
life.
1.
Here it comes. Once it's over 20%, we can put the fuel in. Keep an eye on what pushback's doing. It's all going well. And we're going to put the electrics on bus as soon as the engine gets up to 60%. So we're going to check it first of all. Switch the generator switch to number 1 and number 1. I'm going to put the generator switch down to check. I'm going to check the voltage and the frequency on phase A, phase B, phase C. It's all good. Switch it up to connect and we get voltage and current. So number 1 is started with the voltage and the generator's on. Number 2.
Starting engine 2. Got it. Starting 2.
Excellent, here it comes. We'll do this one a bit quicker as well. It does bus splitting, Sandpatch. I don't think it syncs them fully. Oh, I should probably put the fuel on. There we go.
Operation complete. Set parking brake.
Parking brake set, clear disconnect.
Disconnecting tow. Stand by.
Awesome. This one here, Sandpatch, that's tying the two that's tying the two DC systems together. So it's telling you the DC bus tie is in effect. You know, that's 27 volt DC on there. Okay, we've got 60%, so put it over to check. Number 2, we've got frequency and voltage on 3 phases. We'll connect. We've got current. Let's start number 3.
Starting engine 3. Got it. Starting 3.
It has enough electrical buses total, I think. Many electrical buses. I set the parking brake result. Right, third engine fuel comes in.
Tow is disconnected and bypass pin has been removed. Hand signal on the right. We'll see you next time and have a safe flight.
Oh, it will be marginally safe. We'll do our best.
Engine started.
Kinda.
Engine started. Okay.
Not quite there yet, Felis. We'll get there. Right, it's running. Generator number 3, we'll go to check. We check the frequency, the voltage on 3 phases, we couple it up and we check that we get current.
Generator is connected to the main bus.
We've got 3 generators. Number 2 is not doing anything because...
Right. Engines running. Flight controls checked. Switch to visual control.
Thanks, Felis. We're not doing anything with it. Goodness me. We're not doing anything with System 2. System 2 only runs the slats when all 3 generators are running. Having started the engines, we can take the APU generator offline. We can also switch off the air bleed. So bleed comes off down here. Hold it until we get all 4 lights back on again. Having done that, we'll put the main engine bleed switches on down here. 3 bleeds. I'll increase the airflow until we get a reading again, and we should see the pressurization move a little bit. Come on, aircraft. Oh, you know what? My bad. Let's switch the start switches off and that'll let the pack flow valves open. There she goes. Thanks, Sandpatch. Right, and we'll switch on the air conditioning temperature selectors here. Whilst we've got this here in front of us, air conditioning, it's the same as a modern Western aircraft. The packs cool the air down to a low temperature and then it readmits some hot air to trim the air up. So this is setting your cold limit and this is the trim air setting here. It does exactly the same on the Airbus, it just does it automatically. 21 degrees should do us nicely. I'll just top up the brake pressure accumulator. Check everything else is done. The only light we've got up here now is boosters and steering. So, oh, no it's not. We've still got the APU running. I'll switch the APU off and the system tie light goes off. Let's put the flight control boosters on. This gets the power from the yokes into the flight control system. Let's do the other kind of normal pilot stuff. we need to set the flaps.
Flaps extending.
Flaps to 28.
Slots extending.
We check the trim,
Moving.
it's in the correct position, and we'll also now turn on the Doppler system power. We'll turn on the window heat, put the window heat to low. The runway's just ahead of us, so I'll put the pitot heats on just
28.
now.
Stabilizer -1.5. Slots extended.
Thank you. Put the radar on. I'll forget to do it later, so TCAS can go to TA-RA. And once the radar goes ready, we'll switch it to on as well, because we're clear ahead. Come on, little light, you can do it. There we go, ready, and Meteo. Now that we've done that, again, I'm doing this fairly slowly, we can double check that the autopilot's going to work. So let's recheck the gyro system both ways, make sure it's level. The warning light's gone out. We'll power up the autopilot flight director system. We'll give it a roll axis, a pitch axis, the nav system. We'll give it needles. We'll also switch it to VOR mode, and it illuminates VOR down here. Having done that, if I close the cap on the nose wheel steering, the warning light goes out. Okay. Bleed valve is off yearning. Once the 4 lights come back on, that's the APU bleed valve off. And it will accidentally, if you accidentally switch the engine bleed on, it will switch the APU off anyway, it'll overtemp it. That warning light going off is a good thing. I'll put the steering back to 63 degrees. Now, it's got a checklist built in, and it's a good checklist. It will do voice callouts. Felis will check everything for you. That being said, if I've missed something, I'll need to go through and edit 3 hours of video to mute some of the callouts, otherwise I'll get demonetized on YouTube when this video goes on there. So it's a good checklist, use the checklist. I'm not going to use it because it would just cause me a lot more work. So if you flick that switch on the nose wheel steering and this light continues to flash, something isn't quite right. But for me, we're good to go. So I'm going to extend the landing lights, I'll put them to the taxi position, release the brakes.
63 is on.
Off we go.
Right side clear, ready for taxi. Left and forward clear, attention, starting taxi.
Right.
Check brakes.
Yep, we'll check the brakes. So I'll check it with my toe brakes.
Brakes check, okay.
And I'll also come down here and just squeeze the emergency brakes, make sure it does stop us, and then put them back on. Over to the engineer panel and just repressurise that accumulator one more time. Ooh, ice detection should probably go on as well. And we are on the way out. It's nothing major, the call outs. It's just it's a thing that I don't want to take the risk on, really. So our Tupolev is pretty much ready for flight. I was going to talk about the nose wheel steering. So watch my rudder pedals with this switch switched off. I can now use the rudder pedals and I get no nose wheel steering. The switch forward, I do get nose wheel steering. Now, I think you would have the switch off for pushback to allow the tug to turn the wheel without the hydraulics interfering, but it doesn't work like that with this model because it will stop better pushback from working. So if better pushback isn't working, it's this switch down here. Quick flight control check. Everything else was set on the ramp. And out we go. I've had to turn off, let me turn off 3G FPS as well.
Turn indicator and compass check.
I turned off X-Europe for this aircraft simply because at the start of the week I had a crash with it in X-Plane. I've not had a crash in X-Plane for ages and ages, and I think it was just asking a little bit too much with this aircraft and X-Europe. So it's the default scenery with some ortho today. Hope it's not too much of a thing. It sounds really nice, Toto. It's a nice looking aircraft. Nice sounding aircraft. So I'm going to come to a halt and I'm going to set the parking brake, check the parking brake set, and just double check everything's done. So the Doppler system is on and ready to go. The windshield heat is to low, the pitot heat is set on. We've got everything aligned as far as the trim goes, everything's neutral. Our autopilot, we've got VOR prepared, VOR displayed, we've got the roll and the pitch axis on, we've got the needles and the nav ready to go. We don't use the auto thrust on the Tu-154, and we've got the APU shut down, we've got the turn warning light, and everything else is good. Up here, ice detection switched on, everything else is switched off. I think, oh, I haven't set the stop altitude. Let's set the stop altitude, 6,000 feet, just for giggles, and let's have a look at the speeds. So it's got this takeoff and landing card here. Felis will call them out for you, but we're doing a flap 28 departure. So my rotation speed is going to be around about 240 knots. V2, 260 kilometers, sorry. So V2 plus 40 is a fairly normal climb. I'm going to climb at 300 kilometers here. You've got knots on the inside and kilometers on the outside. 300 kilometers. We clean up 330 and 360, and I'm expecting a slight left turn. So my runway index is aligned on 310 and my VOR pointer set. I think we're in fairly good shape. Now obviously you would do these things in a slightly different sequence in the real thing. You'd do these things in a slightly different sequence in any aircraft. But I'm trying to put things in the position where they're relevant to learn the aircraft, rather than what you would actually do. So talk about speeds on the gate rather than when you get to the holding point. Hope that makes sense. On the original video I did for the Tu-154, I used the auto thrust on departure simply because I wanted to keep it straightforward. And I know that you're not allowed to use it on the real thing, but I just wanted to make it easy to fly and easy for people to understand. And I got about 50 comments from people saying you can't use the auto thrust on the Tupolev. Like, yeah, I know, I mentioned that in the narration, guys. I told you why I was doing it, because I didn't have an FO, but you know, sometimes you just go along with it. Yep, only for auto land. But I'm going to use it on approach Captain Crash. I'll probably get a load more emails for that. Right, Budapest, runway 31 left. I'll just pause on the centre line. Close the cap. Reset the J meter. It's a good idea. Does it have a reset? I do not think it does. No, I think you'd power it off and power it back on again. Sandpatch. I think we're good. Right, the light has gone, and I'm simply going to give it full power. Rotate at the speeds. Let me bring the table back up. And yeah, we get what was that, Wing Viking? You usually get bars to set the thrust. Yeah, exactly, it's done in the rear seat. That's why you've got thrust levers back here. Anyway, off we go. Full power.
Pass-through valves are closed.
It was in the rear. The Wing Viking didn't like that.
Throttles. Landing lights on. Takeoff thrust, parameters normal, holding thrusters.
Landing lights on. Should probably do that.
Speed alive. $200. 220. V1.
Yep, full thrust,
Rotate.
Captain Crash. There we go.
Positive rate.
Gear up.
Gear up.
I'll pitch to maintain
Gear
300
up.
kilometers.
Altitude 50. Turn off and remove the lights.
You just wanted me to switch them on, now you want me to switch them off? Goodness.
Landing gear up.
Okay, flying 300 kilometers an hour. And I'm just going to get to 1,000 feet above. I'm just going to lower the nose ever so slightly, ease the power off just like you do on any other aircraft. And I'm going to bank gradually, not more than 15 degrees initially, towards those flight directors. There we go. Too much bank. There we go. So those flight directors are taking me out on the VOR track.
Pressure 1013 set.
Thank you. And we should be able to just lower the nose ever so slightly and let her clean up.
330.
There we go.
Flaps 15.
Done.
Flaps retracting.
And we get to 360
Speed
and then
360.
flaps up.
Flaps up. Stabilizer moving.
Okay.
Slash retracting.
and we're just going to climb up to 6,000 feet. There's no auto capture on the altitude here. So once the flaps are up, we put the landing gear to the up and neutral position, and then I'm just going to pitch to maintain 250 knots.
Flaps and slots are removed, stabilizer 0.
And a little bit of power reduction because I'm only going up to 6,000 feet. And you see we're perfectly centered on the VOR with the flight directors doing the hard work for us. So it's still flying it manually. Trim it and fly it like any other aircraft, and it's really quite stable. It's got automatic stabilization on the 154. There's a video online of one having a rather exciting day out in Russia when the stabilization wasn't quite right. So I'm just going to back the rate of climb off. It's doing about 3,500 feet a minute. The VSI is in meters per second, so just double it and that gives you feet per minute. Exciting. Yeah, it was exciting, wasn't it? So I'm looking for about 1,000 feet a minute. I'll put it on the 5 marker there on the the VSI. And once we level at 6,000 feet, I'll put the autopilot on. It was too exciting for my tastes, Totarico. Too exciting. Wouldn't have been fun. I brought the power off too much. So yeah, again, this is where Boris in the back would be helping out with the power for you. That's just the altimeter warning. Nice. So it's, I think it's a great looking aircraft. I like the 727, but I love the 154. Right, here we go, 6,000 feet. Lower the nose. Set the power where it needs to be. And with that, I can engage the autopilot. This one here.
Engaging autopilot.
Put them into altitude hold mode. Bring the speed back a little bit. I'm doing 300 knots, but it's fine. And we are flying on our way towards Golf Yankee Romeo, the first waypoint. You can see the VOR is centered here. And on the FO side, he's got a completely separate switch here. He can have a look at both VORs as well. He can set his own index on here, but when we're flying on the VOR, it is automatically set to what the captain's is set to. Okay, so let's just climb up to our cruising altitude. You've seen a level off, we've got the automatic pilot in. I'm just going to wind it up to 38,000 feet. And we're going to put it into the speed hold here, and I'm just going to advance the power. Yeah, it's fairly normal, Winston. These are slipper aircraft. I just work on the basis that in the 70s nobody cared. And off we go. So VOR navigation at the moment. So it's making sense so far. Once you get it airborne, it's fairly docile. Apart from the units being different from what you expect, it's not that bad. On the flight engineer panel here, we should have 1,200 meters on the cabin altitude, and it's doing its pressurization thing. Yep, faster is better, especially when you're burning gas. If I want to adjust it, I don't have a vertical speed control, so there's a couple of things I can do. Weirdly, in this aircraft, I've got roll and pitch channels. If I push the stick, I can break out the pitch channel and keep the roll channel engaged. So it's steering for me, but I've got pitch control. It's one way to do it. Re-engage both channels with the button here. Or I can simply roll the thumb wheel here, and that'll lower the nose attitude as well. So there's 550 kilometers or 300 knots. Go back into V and let it climb away. Once we get that sun away from behind us, you'll be able to see the gauges a bit better as well. Through 10,000 feet, I was going to say Susan. I'm trying to think of a name for our cabin crew. Svetlana. Let's let Svetlana out and do the business here. Actually, it's Hungarian. Somebody give me a Hungarian cabin crew name. So here we are, 60 kilometers to go to Golf Yankee Romeo. let's bring up the navigation system here, the NVU. This is the same as what we've got down there. Okay, it's waiting for 50 kilometers to establish until it starts counting, or till I tell it to start counting. If we look over here, I can put the FO onto NVU mode so we can monitor it as well. Thanks, Captain Crash, that helps. Sophia. Right, so Sophia and her team are working in the cabin. There's 60 kilometers to go to Golf Yankee Romeo. It is really a systems nerd's dream, Winston. Absolutely, it's a navigation machine. I would love to be able to do everything on it by the book. I just don't have the mental capacity for that, so I switch everything on and go fly. But I love the systems, I love the nav kit on it. That doesn't mean to say we're not getting 100% lost on this trip. I could really do with an INS, but we'll see how it goes. Right, 54. When it hits 50, I'm going to switch the calculation switch on, and you'll see this start to count down. You'll also see the other numbers springing to life. Okay? See if it works. 9, 8, 7, 6, 5, 4, 3, 2, 1, engage. So it's now counting down. This is the distance to Golf Yankee Romeo. It should roughly match the figure we've got on the DME counter because it's kilometers as well. It's going to anticipate the turn by 5 kilometers. And if we look at my altitude, I'm about 4.5, 5 kilometers high. So that's the minimum value we'll see on the system here. I'm still navigating on the VOR. So if I switch from VOR mode to NVU mode, indicates NVU, and we can monitor the VOR on the first officer's side. He's got free control over his index now. Hopefully it'll be straightforward from this point onwards. Map angle, yours, this is to do with the RSBN short range navigation system. It's like a how would you describe it? It's a combination, it's like a VOR NDB TACAN system. Designed to be slightly more portable, I believe, so more like a TACAN system than a VOR. Captain Crash might be able to explain it in a bit more detail. It's not a system that I've really messed around with because you either need to use a separate plugin file for the 154 or on Microsoft Flight Sim, where I learned to fly the Tupolev, you get an extra scenery pack for it. Yeah, Winston, it's super having the, well, it's not so good for the FO because they are really working more as a navigator than a pilot, but it's very useful, and we'll see that as we correct as well. So here we are, 29 kilometers. It says 29.5, sorry, 28 coming up now, 28.5. So that's a bit of the slant range showing in that it's counting or measuring the distance from here down towards the beacon, but the system is only measuring it across the ground. Was that loud enough for everybody outside? Goodness me. Yep, it's in the yellows, let's not do that. So we're only going to turn about 20 degrees, so 5 kilometers is a fairly reasonable turn anticipation. Felis has actually provided a calculator on the phone up here that you can work out your turn anticipation, I think, if you really want to. Yeah, they can hear us coming, Captain Crash. The landing lights are not a factor. They just need to look for our smoke trails and listen out the window. Also on the takeoff, you can do a derated takeoff, Captain Crash. You don't need to use full power. I can't remember, there was something when I first started flying this that didn't quite work right. Maybe it didn't do the call outs, or maybe there was a warning or something, but it didn't like it. It might be better now. I've honestly not gone back to try it. So we are approaching the Golf Yankee Delta. From the Golf Yankee Delta, we're going out to Fishermen, FMD here on 297.7. So from here to here, we read this line, 297.7, and a mag track initially of 297. So let's see what happens. 5 kilometers. There we go. So it's flicked over to system 2. It's now commanding a turn, and round she goes. Let's look on the map here. There's Golf Yankee Romeo. We got to within 0.8 of a mile of it. It's pretty good. And as I said, the magnetic track for this leg is 297. So let's put them up here. 297, I'll put it on both the indicators. You just don't push the levers full forward, Captain Crash. 297, I'll set it on this here as well, simply for my awareness. 297. I'll set it on the FO's side because it will help him over there. 297. And we also want to move the VORs on one, so I'm going from Golf Yankee Romeo to FMD, so the right hand side goes on to 110.4. 110.4. So here we go. On the FO's instrument, we can look at VOR number 1 or VOR number 2 without affecting the steering on the aircraft. The aircraft steering by the number 1 side. This is the VOR behind us. Flick it over. This is the VOR ahead of us. And, you know, it's close enough for the moment. So I need to set my NVU to do the next leg. I've only got 80 kilometers to go. Before I do that, because I'm getting a valid signal from FMD 110.4 and I'm navigating on the computer, I'll put 110.4 on both. So the Golf Yankee Romeo behind me, I'm not interested in that anymore. I need to set up for the next leg. So from FMD, my NVU course, we'll call it, 292.1. I'm going to put it on the one that isn't illuminated. So 292.1. And we'll also set the distance as 436 kilometers. So FMD 292.1, 436 kilometers. Make sure it's set to SP, it's the point value here. It's always that one that will change. I'll put it into fast mode and I'll scroll left until this says 436. Fair bit of scrolling. At least you can hold the button down. I'll need to go into Mach hold as well in a second. So it's 436 exactly, and we're done. We've got 292.1 and 436 ready to go. Where are we? 0.75. I think we can keep accelerating or keep climbing in speed hold for the time being. Yeah, XNVU is the tool to use for this, Captain Crash. It's by far the best NVU navigator for X-Plane. Thanks, JSnap. I'm all about self-promotion as well. I've not tried that, Sam Patch. I need to have a look at it. Right, so with any kind of navigation, set yourself gates, set yourself points to check things out, okay? And at 50 kilometers, running down towards the turn, I'm just going to double check what I've got on the system here. For the NVU, it's 292.1, 292.1. My S distance is 436, and it says up here, 436. My next magnetic course is 291, so I'll put that on the right hand side here. And that 291 course will take me to Erlangen, which is 114.9. So let's put that on the number 2 side, 114.9. So the radio aids are set up for the next leg, the NVU is set up to do the next turn. And if I wanted to do this using the VOR, it is simply a case, I'm just going to move X-Plane's time on so you can see the gauges. if I was doing this using the VOR, I'd simply synchronize the heading bug, put it into steering. The CS button there just lets you do steering on the bug, and do it exactly the same as you'd fly any other VOR aircraft. The NVU takes care of the turns automatically. Note here, 436 kilometers is what we've got set in. It's already counting, showing 467, so it's basically taking this value here, adding this value here on roughly, and that's what you get on there. It also shows a Z value, which is across track. So we're flying ahead. If you imagine, follow my mouse cursor, we fly ahead. We're going to get to a waypoint and then turn left. So if I extrapolate with the mouse cursor down here, my course is currently to the right of the aircraft, and that's what it's showing here. It's basically already predicted the turn. It's already starting to show that this line here is the next course, and we're to the left of track. It's fairly clever. There's 0.8 Mach. I'll go into Mach hold, and she should climb a little bit better from now on. Is everybody still with me on the navigation front? More or less. Not quite. It's a bit less involving from this point onwards, so I'll try and keep up with your chat a bit better. Still with you? The rotary dial on the NVU, which one, yours? This one here, the ZB SP values. Okay, yeah, so we'll look at that just as we make this next, or after we make this next turn. So we're heading for Fisherman. If we have a look outside, this one maybe, can I do this one? That noise down. Where is Vienna? Should be Vienna here. So Bratislava should be over here somewhere. Ah yes, this way. The problem with the NVU yearning is you've really got to commit to doing a few flights with it. Exactly, Winston. The NVU helps automate your VOR workflow a little bit. So it turned, whilst I was outside, sequencing quite happily out towards, where am I going? Sequencing out towards Erlangen. So we're now on the FMD to Erlangen leg. Okay, my magnetic was 291, so I'll put that on both of the instruments. And here's where we can do a little bit of correction, okay? Because I've got 430 kilometers until the next point. So probably a reasonable time to make sure that we're on course, because you can see on this, I mean, that's pretty good, to be honest. It's fairly accurate. I'm not actually receiving Erlangen just yet, it's a bit far away. But if I look on the FO's side, if I look at the FO's VOR, it's coming in. We're still quite close to it, but I'd like to be a little bit more accurate than that initially. So what we can do is correct onto the VOR, and then we'll take out the error that we introduce. So an important concept here is it doesn't matter what I'm using for navigation, the NVU is still running in the background. As long as the calculation switches on, the Doppler's doing its thing, it's still counting those numbers down. Okay, so what I'm going to do is correct the track error. I'm going to correct to the left ever so slightly. So I'll set the heading to the nose of the aircraft, and I'm going to put it into CS mode, but I'm going to go through the VOR mode momentarily. So I'm going to click VOR and then CS. That puts my main display onto VOR, and I'm simply going to steer ever so slightly towards it and capture the VOR track outbound. So when you're thinking about flying a VOR, has MD looked at an airways chart and wondered why when you're flying from one VOR to the other, you may, for example, leave on a 270 course from one VOR and arrive on a 272 course into the next VOR. Have you seen that? It's because the VORs are aligned usually to magnetic north. Yeah. So when you're flying a VOR, although you're flying a magnetic device, you're actually flying a straight line over the surface of the Earth. You're flying a great circle track when you're in a VOR leg. Whereas when you're following a magnetic heading, you're flying, what's the name for it? A loxodromic path, I think it is. It's orthodromic and loxodromic, probably. Basically, VOR is great circle. It's just referenced off a magnetic device. As the needle comes into the middle, I'm going to put it into VOR tracking. Yep, rum line, that's the one. No, a VOR is a great circle, Captain Crash, because the radio signal can't be bent by the compass, so it flies in a straight line. So it's basically a great circle track. Would be if you followed a VOR to infinity, you'd be following a great circle line. This aircraft allows you to fly great circles using the gyro system here. Let me put it into VOR capture mode, and I'm going to get ready to capture the altitude as well, 38, and then we'll do some corrections. So with a INS, you correct using a DME. There's a height capture, and I'm just going to set about 90%. With an INS, you correct using a DME, typically. With this aircraft, you can correct using the RSBN. It can do it semi-automatically. With a VOR, you got to do it manually. So I'm flying on the VOR. The NVU is still calculating. VOR's here. I can have my FO look at the NVU, and now he says, well, we're slightly off track as far as the NVU is concerned, but the VOR is spot on. And this is what yours was asking about. So I've got, essentially, I make it bigger just for a moment, then I can point with my mouse. I've got to be really careful here, because if I flick it into manual accidentally, the world falls apart and it stops working. So off is off, it doesn't do anything. S and Z, it doesn't matter what side you use, it's the same thing. S and Z, it will change the current S and Z values, the one that's got location marked on them. Z and SB are for the beacon, and P is for the point. Okay, so point is the next waypoint we're navigating to, and beacon is the one we're flying towards. Our location is where we're flying towards at the moment. Okay, I've not updated this, so it's only the top side, the number one, we're interested in. You can see that it's got an Z error. Z is cross track, S is forwards and backwards, and Z is left and right. And all I'm going to do is flick the needle, the switch around to Z, and if I do it from this side, you should be able to see it all happen simultaneously. I'm going to double check I'm on Z, and then I'm going to adjust this. You'll see the Z value change here, and the needle will synchronize. Okay, so I'm basically eradicating cross-track error down to 0, and the needle is in the middle. Okay. Now, while I'm there, I'm now getting a signal from Erlangen. Erlangen is 348 miles away. This thinks it's 346, so it's about a kilometre out. I'll flick it to S mode, and I'll simply back-click a few times, holding it on 345 until it clicks through 345, and now we should be perfectly on track. Yep, azimuth, I think you're right, Vinny. Having done that, check on the FO side, make sure it's still centralised, and flick it back into NVU mode, and we're back with a fully aligned system. So we've made a slight course correction, a slight track correction, a slight distance correction, and we're flying towards Erlangen. We left Fishermen, towards Erlangen, not being able to receive Erlangen, so we're still tracking Fishermen behind us on this side, and Erlangen here. But having done the transfer, or having done the correction, I'll now bring Erlangen up on this side as well, 14.9. So all it's doing, in simple terms, is flying this track for this amount of kilometres. Nothing more, nothing less. I can pre-select the next track I wanted to fly, so we're doing the 292.1. The next track is going to be the 285.7, so check the one that's not lit up. 285.7. Yep, 285.7, and our distance is 185.6. So make sure we set SP, that means it's going to affect this value here, and we wind it to 185.6. Nearly there. And it's not overly precise really, is it? And the next course is going to be 287, so I'll put that on the right hand side just to remind me. And we are happily tracking on the way towards Erlangen. I think it's great fun. It's different from what you have in aircraft like the 727 for sure. It's different from an inertial navigator. You've got to stay on top of where you are. So doing it on Avatab is awkward. I prefer to have it printed off so that I can score out the lines that I've used, otherwise it gets confusing. But it's entirely doable. Amy, a run line is when you fly a magnetic track, when you fly based on your compass. So imagine if you will, you are on the Greenwich Meridian on the equator, okay? So you're somewhere in Africa, I guess, and you want to fly to the international dateline also on the equator, okay? A run line, you could fly course 090 degrees and you would fly all the way around the equator, or you could fly course 000 degrees up over the pole. It's a fairly bad example because the distances are similar, but if you do it for latitudes, let's say the mid-40 latitudes, so somewhere around France and Spain, and you wanted to fly west to North America or Canada, you could fly westbound on course 270 degrees and fly around the latitude lines, or you could fly northbound on the northwestbound on the Great Circle track. So by flying a Great Circle, it's a much shorter distance. And that's why this system is designed to fly great circles. It's designed to allow you to fly great circles because it's more efficient than flying on a run line. But over general aviation distances, a run line doesn't make any difference. You bought it today, Ross? It's an old aircraft. Let me make sure that I'm not going to break anything. So to set expectations, if you're thinking about buying this aircraft, I love it because I've flown the Tu-154 in Microsoft Flight Sim for years, and this is as good as. It's very heavy on the system, right? It's doing a lot of stuff in the background. So if you're on a marginal system, it's going to be difficult. And it's got a fairly steep learning curve, for sure. But it really is it's good fun. I did a flight in the Airbus from London down to Egypt and back again. And I say I did a flight. I got to cruising altitude and I went and watched the TV, and then I came back and did the landing. And you know what? It didn't get lost. It did exactly what it was supposed to do. It does what Airbuses do. On this thing here, you couldn't do that. It just wouldn't work. So you've got to stay involved with it, and that's what I really like about it. You've got some interest in the cruise phase. Whilst we're in the cruise, I got a lot of new followers on the channel as well. TimSim1234, Turbinator, Cheyenne Pilot, Sim for Fun, 10 Cent Tacos, Tuba Flight, iPollo, and Amorphous. We've got the Wing Viking as well, thanks Bernard, and Alex Hook, Smugglarn, JSnap, thank you, MSAir, Mattia, and yeah, thanks all. Thanks for following the channel, much appreciated. So I hope you can see that once you understand what this does, once you understand how this navigates, it's not difficult. It's got some things that you can't do, right? You cannot fly direct like you can on a FMS, right? Now I say that, you kind of can fly direct to the next waypoint. This is a 7-degree turn to the left it's going to do when we get to the next waypoint, when we get to Erlangen. It already knows the course from Erlangen. It knows the course from Erlangen to Frankfurt. Yeah, Frankfurt. It knows how to do that. So I could basically turn left and point it roughly towards Frankfurt, and it wouldn't confuse the navigation system. But I couldn't navigate in a perfectly straight line to Frankfurt. If I change the waypoints over, if I sequence the waypoints, it'll track towards this. It knows it's currently about 20 kilometers cross track. So it knows that to get from Frankfurt to Erlangen, the line would put me over here and I'd follow this line here. So it would turn this way and then fly that way, which is not really what you want for a left-hand turn. So you can use it to reference your position, but you really can't fly directly in the same manner as you would with an INS. It's got the ability to work with the GNS 430 and the KLN 90. It originally had the KLN 90 only. Yeah, Sampatch, that's what I was really interested in. So it's doing, it's almost doing what the old school RNAV avionics could do. They can effectively move RSBN position from one point to the other and then fly along with that, I think. You could use the GTN 650, that's true as well. It depends what floats your boat. I haven't flown this online, I haven't flown in an air traffic control environment. So the fact that I have to stick on the track isn't a problem. But if you want to fly it on VATSIM, I can totally understand where having the FMS, the GPS would be useful. I just think this aircraft represents a reasonable, a fairly good value for money. You've got a lot of enjoyment potential in this aircraft, a lot of messing around, a lot of fun you can have. It's Pancake King in the chat. Pancake King could rip the wings off this thing. It would be good fun. KNS 660 FMS, JSnap, that would be interesting. I really want to see an old KNS 80 for general aviation, an RNAV navigator, or the narco equivalent. That would be pretty good as well. Yeah, absolutely. Absolutely, Bjornar, the Winged Viking. In the later years of this aircraft's operation, they had FMSs and they had the NVU system removed for sure. Would it have sold better if it had in FMS? Possibly. Would it have the same appeal for me if it was able to do it automatically? Maybe not. I enjoy the quirks, I enjoy the operating interest in it. But that's just because I fly it offline and because I am a navigation nerd, for want of a better expression. I love the avionics, I love the systems. That one there. Excellent. So we are counting down towards Erlangen. We have got 114.9. After Erlangen it's Frankfurt, which is 185 kilometers, and it's 114.2. So really the next interesting thing we've got to do with the NVU is transition from the departure magnetic reference to the arrival magnetic reference. How can I demonstrate this without breaking it? So Remember on the ground at Budapest I flicked back and forth between magnetic and gyro and there was no movement? If I come to the overhead now and I switch the number 2 over between gyro and magnetic, you see there is movement. Now if you're flying it on the GPS, then just leave these switches down, leave it set to mag and all will be well. It's just like a 727 in that respect. But to fly with the with the NVU, you should have it set to DG. Yeah, it's very similar, Captain Crash. The difference, the NVU is essentially, it's the auto switching logic that the EN24 stuff doesn't have. Just reading Sandpatchy's thing about the RSBN. Oh, okay. Sandpatch, is there RNAV scenery for Western Europe? Is there RSBN scenery for Western Europe? The problem I have is I don't know my way around Central Russia well enough to know exactly what would be a representative flight. That's why I tend to fly the Eastern European liveries, because they're airports that I'm familiar with. There we go. Where's my next waypoint? There's Erlangen. We'll see how accurate we get. 164 miles to go. 64 kilometers, sorry. There's 162, 100, yeah, so it's there. Yeah, so it's got the internal RSBN database. There was that was adopted from some other developer, I think, and I know you can put them into XNVU as well. What I'd like to have is the ability to, if it's a text file where the NVUs are created, I'd like to create a series of RSBN waypoints that I can use for navigation between airports I'm familiar with, just to help learn it. I just get lost otherwise. It's the cross-checking. If I know roughly where I am over Germany and Austria, once I get further east I get quite easily lost. Well, first world problems. How are you getting on, Winston? Are you ahead of me or behind me? Hey Jono, didn't see you there. Thanks for joining the stream. Did you all enjoy Toto's stream earlier today? You have fun watching the Challenger do its Challenger business. It's flying, Pancake King. Well, the right way up. It's shiny side up and no warnings. Rule number 1. And we got off the runway, off the ground, without any parking brake related malfunctions this evening. So that was a good start. Your 100 DME to Erlangen, yeah, so I can switch mine over from kilometers to miles. Yeah, I'm 73, and you're below me as well. I'm doing 0.84, I think, Winston. Sandpatch, what are the auto manual switches for on the nav radios, out of curiosity? 0.82, Winston. I've slowed down a little bit. Got to give the 727 a little chance. Huh? Do you want to see my fuel burn though? That's more impressive. I've got 12 tons of fuel remaining in the tanks, and I'm burning 1.6, 3.2, 4.8, nearly 5 tons of fuel an hour. 5 tons of fuel an hour with 12 tons in the tanks. Not too bad. It's got a lot of wing. The Wing Viking, it's capable of fairly high altitudes, and to be honest, it's not really that heavy either. Does this break it if I open it? I don't think it does. we had a lot of extra fuel capacity. It's fairly long range aircraft and we're using it for a fairly short distance. At heavier weights it struggles a little bit, but at these weights it's awesome. We're just power on number 2. I want to go fast. That would mean I'd have to slow down. No, don't do that. That would mean I'd have to really slow down. I don't want to do that. Okay, I'll give that a try then, Captain Crash. I'll put an RSBN station somewhere that I'm familiar with and work out what it does, how it works. It's very much an aircraft for experimenting and playing around with. And that's what I like about X-Plane as a sim in general, is that it is a sim that supports essentially experimenting with your aircraft, whether it's the airfoils or the systems, or in my case I like just exploring what the aircraft systems, the nav systems are capable of doing, and X-Plane really gives you that. I quite like having aircraft that you can go from A to B in, for sure, but there's nothing quite as fun as getting airborne in this sort of aircraft and just working out how it works, and then working out how to employ it, how to make it do the job that you want it to do. I find that particularly fun. 100 kilometers to go. We'll look at Mr. First Officer here, tracking on the VOR. So inbound towards, that's Frankfurt, that's Erlangen. Inbound towards Erlangen, we're slightly off track. That is probably because, as I said, your inbound to the VOR is not the same as the outbound to the VOR. So maybe the 287 that we've got selected, hang on, maybe that's why. Have I confused myself? 114, so we're going from Erlangen to Frankfurt. It should be 281. What have I done? 14. Never mind. How do you know the inbound course? You have to get that from the Airways charts, Sandpatch. There's no other way of doing it. You could do it on the GPS and flight survey it yourself, which is one way of dealing with it. That's one of the things I was doing a while back, doing just a few routes and flying them on the GPS and centralising the VORs at mid-track to make sure that I got the tracks as X-Plane had. 281.3 and 287. Yeah, okay, I see what I've done. No dramas. So if you were to load up a GPS track, Sandpatch, from one VOR to the other, then just fly to the midpoint, centralise the needles and write down the values that you've got set, and then you know that you've got an outbound and an inbound. What I do for VOR flying, sorry, just before I do this, we're just approaching 50 kilometers to go. We are currently navigating from Erlangen to Frankfurt, so the next waypoint set I'm interested in is Frankfurt to Brussels. Frankfurt to Brussels is... I need to do this. Frankfurt to Brussels is... No. We're going towards Erlangen, aren't we? Erlangen to Frankfurt, that's what I've done. Confuse myself too easily sometimes. 14.9, okay. We're counting down towards Erlangen? We are. So at Erlangen, the next course is 285.7, check. Distance 185.6, check. 281, that's the next course, not the current course. Okay, we're good. So it's all checked out. Roughly. When I'm flying VOR to VOR in Europe today, rather than worry about what it says on SkyVector and what the realistic 100% real world route would be, well, there isn't a 100% realistic real world route anymore. And to be honest, these things in the 60s, 70s and 80s were changing so much that you've really got to pick almost like pick a specific month and the real world route would be valid on that specific month, and then it would change again. There'd be a different radio aid, or there'd be a change of route or a new intersection. So I simplify it, and I simply go into SkyVector and I do the route from my departure airport to the arrival airport. And if there's a VOR nearby, a big international airport that I'm familiar with and that I know has been around for that sort of length of time, I'll rubber band the SkyVector course overhead the airport. So in this case it's Erlangen, which is beside Nuremberg, Frankfurt, Brussels, Coxey, Dover. So there's a little bit of local knowledge here that I know you can go to Heathrow from Coxey, Dover, Biggin. But this route here is simply the most direct route using VOR beacons near to big airports. It really is as simple as that. And it might not be compatible with VATSIM, but what I'm trying to do here is to remind myself to stay current on VOR navigation and traditional navigation. The fact that the particular radios I'm using today aren't the radios that were in use 40 years ago doesn't change the skills involved to fly those radios. Okay, it doesn't have to be exactly the precise route that you're flying. It's the same as an Airbus FMS. Okay, if I set it to navigate to point A rather than point B, you're still using the keyboard, you're still typing the thing in, you're still getting the aircraft airborne and navigating, you're just using a different waypoint. So I think sometimes people worry overly about getting the precise route exactly correct when it's, you just want to go fly. Here's Erlangen. We are 10 miles away, so we're counting down 18 kilometers, and we are 11.5 kilometers high, so we are about near to the overhead. Let's see how it does. Sandpatch, perhaps Little Navmap can do that. Otherwise, you would have to basically plot it out on SkyVector. You'd have to put the track in and then read it off the compass rose. That's why VORs have got the compass rose on them, incidentally, because not all VORs are properly magnetic aligned, so you would just simply read it off the map. The other thing to keep in mind with VOR navigation is expected precision, right? We are used to GPS navigators. There it goes, it's turning 5 miles before. It's going to be about 2 miles out, maybe 2 miles, 2.5. It's not too bad. We're used to GPS navigators flying precision navigation, right? But that is not the era that these aircraft are from. It's not the expected navigation performance the controllers would have. A lot of the time you're not even flying in a radar environment, you're separated procedurally, so it doesn't make a huge difference. If you're half a mile here or half a mile there, airways were they're always 10 miles wide. I think they're even wider than that, and that's why you've got a maximum distance between VORs as well. The airways are set wide enough to accommodate a drift. As you get further away from a beacon, you're nowhere near as accurate. Winston, I have got nil wind, so I have got the environment itself is helping me this evening. So if I wanted to, I could go back, look at the leg that we're on, which is Erlangen to Frankfurt on 281. We look at the FO's side here. We look for that to come in. I'll put 281 on here. Again, it's just for display. 281 is set, but really, it's not. It doesn't matter so much. Yeah, that's exactly right, Sam Patch. That's my view on it anyway. Now, some people disagree. I want to enjoy flying the aircraft, and if I'm spending 2 days looking at maps to try and work out a realistic route, I'm not enjoying that. I just want I just want to go fly and have fun. And I find this fun, I find this enjoyable and satisfying. And like you say, it's single pilot. So let me stay on top of what I'm doing now, because I'm in danger of getting confused again. 281, 285, 281.3. As a general rule, probably not a good idea to live stream this if you're just learning how to do it, because you really need to concentrate. You know, your workload is high-ish. I'm just going to use this. How am I going to do this? I want to see how far off course I am here, just to see if it's worth correcting. Maybe. You know what? It doesn't matter just now. We'll fly this leg and we'll correct on the way in towards Brussels. So what I'm going to do is set up the navigator to navigate from Frankfurt to Brussels, because we're on the Erlangen leg now. So it's this second one I'm interested in here. We're doing the 285.7, that's live. So it's 292.5. That's convenient, it's only a little change. 292.5, and my distance 305. So again, SP, it's changing the point value, and it goes from 436 to 305. Hopefully this is starting to make a bit more sense now. Again, if you've got the aircraft, just get airborne and mess around with it and give it a go, because you'll learn a lot more by doing that than reading about it over and over and over again, or watch me waffle on about it. 292.5 from Frankfurt to Brussels, 305 kilometers set and checked, and the track is 287. Yeah, I got one stage ahead of myself previously, so that's 287 for the next track and 281 for the current track. And yeah, don't use a PDF. Print off the flight plan, score out the legs that you're done with it, make notes on it to say that you've done it. Just basically keep a nav log going. It would always be the SP. You'd put the next distance in, yours SB Sierra Papa here for the next one. It swaps back and forth, so these lights will go on and come out. SB is, sorry, Sierra Bravo is the one that it's currently using, and I think that's for the RSBN stuff. Sierra Papa is for the next distance. The next distance after this waypoint. Half-scale deflection. We could correct it, I suppose. How far have I got to go? 100 kilometers? 100 kilometers? Is it worth correcting it? Nah, just leave it. Yeah, you've got to stay on top of it, Vinny. It's one of these things that you just need to commit some time and go and do it. I hope that, having watched this, you are, if you've got the Tupolev, you're inspired to go and give it a go, because it's something that otherwise you don't get to do in a simulator. Yours, that's a little program called XNVU. It produces a NVU flight plan for you. You just load the waypoints from the X-plane database. It even gives you the frequencies and the runways at your destination and your departure. So it's everything you need to do NVU navigation, and if there's MD in the stream that is doing anything to do with carousel inertial navigation systems, then this sort of thing, a tool to produce these, it's all you need for INS navigation as well. What I would really have liked to make this more accessible for all sim pilots, and I tried to feed this back to Felis for the upcoming 747 as well, is you want to make it accessible, right? So what I want is I want to be able to use the systems on the aircraft but I want it to be easy to begin with. Okay, so this flight plan here is great. Having a pop-out menu that lets me choose an X-plane waypoint and have that either read the values or having a button that I could click and put it into the navigation system would be really useful. On a carousel navigator, having a pop-out waypoint reader here where I could put in a waypoint based on its current text name. I could type in I don't know, where we're navigating to, FFM. I could type in FFM into a pop-out box and have that read the lat long and either display it or put it into the box automatically for me. It just makes, it's like a stepping stone. It's like you don't want to have to look at the charts, you don't want to have to understand correcting lat longs from degrees minutes seconds to degrees minutes decimal. You just want to be able to fly the aircraft initially. And I think that would be a good thing to have on any traditional navigating aircraft. Yeah, I'm using the VORs simply to reference them, yours. I've used them to correct once, but ultimately it's just ticking away, doing what it does. I could have the VORs completely turned off and it wouldn't mind. Can you do that on the 747 Sandpatch? I didn't keep up to date with that. I was looking for the ability to type a waypoint name in rather than the lat longs, to make it so that if your VATSIM controller says direct levy, you can go to the box and rather than have to get the charts out, just type in a levy into a little window and have it do it. I thought that would be useful. Yeah, Captain Crash, I used that as well. The automatic data entry unit cards, they were pretty useful. If you have a look on YouTube, there's a video called Jet Jockeys, and it's from the 1990s with British Airways 747-200 flight, and they show a 747-200 with the carousel navigators, the carousel units, and it's got an FMS computer that is using the carousel nav data. So you've got two FMSs and the third place is still the carousel, and that's a nice thing. That'd be a nice thing to have. We've got 50 kilometers to run, so just to double check, we are navigating from Erlangen to Frankfurt on the 285.7. Our next waypoint is Frankfurt to Brussels, 292.5, 292.5. 305 kilometers, 305 kilometers. For the VORs, it's 287. I've got 287 ready to go. We're still counting up and counting down. So we are Erlangen to Frankfurt. I need to have Frankfurt behind me, 14.2, and Brussels ahead, 14.6. Excellent. Yeah, there was loads of options, the Wing Viking, for carousel initially. The data entry is where you go wrong with that. You know, typing in lat longs is where navigation falls apart. So in the real world, you would always check the initial true track. The operational flight plans would have the initial true tracks printed on them, and you go through the waypoints on the carousel, checking the initial true track and the distance to make sure it matches with your flight plan, because that's the easiest way to catch errors with your lat long entry. Sandpatch, the Z error, this is the current leg, so its cross track is 0, and this is for the next leg. So because the next leg is angled differently from this leg, I haven't got time to do it. 292.3. Watch this value here. As I change it around, you see my Z value changes. That's because this is the cross track now to this desired track. Yeah, it is. It's challenging for sure. Gross navigation error, exactly, Captain Crash. And that's where those named waypoints. You know, you've got waypoints like 60 north, 15 west actually exist in the computer database now so that you don't have to type in the values, you can reference them by name. Just another way of minimizing those issues. How are we getting on? Well, there's a little bit of error. I don't know, we'd still be able to find Frankfurt. I feel that we'd still be, you know, quite able to sort that out. What we'll do is on the next leg we'll recorrect the cross-track error, the distance to go error, and then we'll change from the departure datum to the arrival datum. Sandpatch, we might need the speed brake if we were to do that from here, I think, but that would be fun, huh? I'll give it a go. A couple of orbits, it'll be good. So we're about 3.5 miles, I think it will count down to 3.6. So yeah, let's correct it on this leg again so you can see that correction. So we're navigating from Frankfurt here out to Brussels here. We've got 300 kilometers to do the correction. To double check what I'm going to do, the leg from Frankfurt to Brussels, the initial track is 287, so let's put 287 on here. Okay, and use my FO side here to check on the VOR. So what I'm going to do is synchronize the steering, put it into steering mode via VOR momentarily. That gets VOR presented, and then I'll just do a gentle intercept onto the VOR. And keep an eye on your cross-track Sandpatch. Here's your Z value. So although we're not navigating with it, it is still counting. I've never been able to do a precision approach, precision radar approach to Puerto Rico. I've done surveillance radar approaches, but never precision. I could never get anywhere with an instrument aircraft that would let me do that. Isn't my course 293? Have I done it wrong? 292. This one here. Frankfurt, well, you're right, that was me messing around with it. Okay, well that's not the end of the world, that's a good reason to fix it. So I'm going to change, good spot Captain Crash. So 292.5, but we are correcting on the VOR. So 292. Frankfurt to Brussels 292.5. VOR is in 287. Yes, that's correct, because 292 is the magnetic datum as we originated at Budapest, whereas this is the magnetic datum for the VOR itself. So you'll see that as you start off, they begin the same, and as you get down to the far end, they're quite different, but the arrival datum they match up with. So the VOR is always at the station, whereas the NVU nav is at the departure datum or the arrival datum, depending on which one you swap over to. Make sense? Maybe it makes sense, I don't know. I hope it makes sense. Here's the VOR coming in, so I'll click it into VOR mode, and we'll have to correct that error that we introduced on it. Thanks, Yearning. Thanks for joining the stream. Hope you enjoyed it. Oh, I'm going to use the reversers in flight. You bet. You betcha. It's going to happen. I think it would be fun, Captain Crash. I've never had that opportunity. Mr. Chu, thanks for joining. Hope you're enjoying the stream so far. I thought it was time to do some NVU nav. I think the flight sim internet has become lazy with GPS navigation. Let's do some old school navigation and get profoundly lost and have a good laugh about it. That being said, I'm using the VORs because I put the wrong value into the NVU, so we're just correcting that just now. Right, so looking at my map here, I have established, this was my initial track, it was wrong, now I'm flying outbound from the Frankfurt VOR. It's 50 kilometers behind me, and we've got a good course away from Frankfurt. So what I'm going to do is simply select the Z value on here. It's showing an 8 kilometer error. I'll bring it down here so you can see it simultaneously on the FO's side. I'll put the FO to NVU mode. You can see that same error. Double check we're on Z mode, and I'm simply going to remove that Z error. You see the value counts down, the needle comes towards the middle. And when it gets to 0, it's all centralized. So I'm eradicating the cross-track error. I can then go into the S mode, and I've got a distance. I'm going to use the far end because that's slightly more accurate than the one closer to us. And I've got S lit up here, 239. I'm just going to hold it back on 239 just for a little bit, and then we should be back to where we were before. Okay. Now, because I introduced a little error to it by having the wrong value set, what I'm going to do is I'm going to leave it flying on the VOR just for a minute or two, and I'm going to double check that my Z value doesn't increase dramatically, because that tells me that the NVU is still clicking away. It's believing this course is working for it. It's all good. Yeah, you'd certainly need to be an expert if you're going to do this. I think it's like everything else. I think if you do it day in, day out, you get kind of used to it. So that Z value is increasing. We've gone another 10-15 kilometers. All is good. And 227. Let's put it back into NVU mode momentarily. So we are tracking from Frankfurt to Brussels. I've got 14.2 on the left side and 14.6 on the right side, so that helps me stay aware of what I'm going to do. Thanks, Seatback Pocket, much appreciated. I always like reading your kind comments on the YouTube channel. So we need to transfer from this 292.5 onto 282.6 because we want to move from the departure datum, the red values, to the arrival datum, the blue values. And there's a fork value of minus 9.8. Keep that minus 9.8 in mind. Okay? What I have to do is to make the directional gyro 9.8 degrees different from what it was. How are we going to do that without getting completely lost? Well, that's tricky. It is tricky. What I'm going to do is I'm going to zoom in here. Remember, we've got a main gyro and a reference gyro. So this is called transferring the datums. I'm going to bring up the overhead, so I need that as well. So I'll put the overhead here. Can I get the ABSU on the same screen? No. Let me put this up here. This is where it gets messy. ABSU is here. Right, so what I'm going to do is I'm going to change the reference datum. I'm going to move the reference datum by 9.8, okay, because that's the calculation we've got. Frankfurt to Brussels, 9.8. So what I'm going to do is switch the correction to the reference gyro. This is the little spot on the outside here, and just move it 9.8 degrees. Now, can you measure 9.8 on that? No, I can't either, but we'll do the best we can. It's roughly 10, isn't it? So it's going to go from 292 to 282.
Setting up compass.
And it goes. 282. Roughly there. So now the FO's side is pointing in the right direction. Let me remove some stuff from the screen. If I was to change the main gyro, the aircraft's going to get lost. Okay? If I was to put it into compass steering mode, the aircraft is still going to get lost. So what I'm going to do is the FO's gyro is pointing in the correct location. So I'm going to move the FO's gyro course steering pointer to the head of the aircraft. I'm going to use this little knob down here to make heading select from the right hand gyro rather than the left hand gyro, and I'm going to put it into course steering here, and if we're lucky we get a very minor change but nothing big. Okay? Now the next bit I've got to do fairly promptly, otherwise we'll introduce a lot of error. I'm going to come back down here and I'm going to move my reference gyro to match, move my main gyro to match the reference gyro. So let's bring up the overhead again and let's change the main gyro and let's just slew it all the way around. Now you do this heads up, obviously the pilot would monitor it to make sure you're not getting any weird things happening with the aircraft. We shouldn't do, let's just trust that we're not getting anything weird happening. Back outside, yep, it's all good. Then what we've got to do is change this 292.5 to 282.6. And this is the bit that we can't really delay with. Once we've changed one, we've got to change the other. Okay, 282.6. Done. Okay, having done that, we correct our Z value because we didn't steer, so we shouldn't have any cross-track error. And we just verify that our distance to go remains the same. Having done that, we can realign the heading bug there, change back over to left side and simultaneously go back onto NVU. We're now transferred on the Datums. And Sandpatch is exactly correct. Every single thing you can do, you can screw it up. So what we do is we fix the first officer's gyro, we change the first officer's gyro by the fork value, we move the navigation control of the aircraft to the first officer's side. Having done that, we fix the main gyro, we eradicate the errors, and then we put it back up again. So you've got to be careful with it, okay? And you do it close up to destination because you'll have a lot of errors with it. And Totorico's right, I mean it's 60s, 50s technology here. It gets tricky. Having done that, we need to set up the next course. So we're flying the Frankfurt leg on the 282.6 now. We need to set up the next leg, and remember it's the blue figures we're going to use now. So 276.1. This is a very wordy stream this evening, so I apologise if there isn't quite as much interaction. I hope you are finding it strangely satisfying. 276.1 and the distance is 133.7. It is on SP now, 133.7. Roughly there. The next course, magnetic, is 279. So let's put that one there. 279, and we've got 14.2 to 14.6. Perfect. So we're set up to navigate from Brussels to Coxey on the NVU calculator. We'll double check that at 50 kilometers to go as well. Oh, there's one more thing on here. It does a top descent calculation for you as well. It shows you top descent is 40 kilometers roughly before Coxey. So that's one for the next leg. So I hope you will not have this sort of navigation experience in the Challenger. I think the Challenger is going to be the epitome of modern navigation solutions. You'll have an X-plane aircraft that will do departures and arrivals, and everything it's supposed to do, it'll pretty much do it. This aircraft, you've got to be on top of it. Once I've changed the datums, I like to double check on the map here, just to make sure that it's still roughly drawing a straight line. That tells me that I'm more or less good with what I've done. You prefer the explanations, Rossler? Well, that's good to hear. I'm glad you've made the stream as well. For the next week, I was thinking about doing the stream a little bit earlier because it's quite late for people slightly further east of the UK. This stream, it works for me being a little bit later around the house. Let's have a look on the outside. Watch your ears. The weird thing it's got is this contrail. Do you see the contrail shape? The engines have obviously got significant angular displacement on them, as you'd expect for this sort of aircraft, but X-Plane's contrails are a little bit funky in that case. Sandpatch, usually flap 1 plus F would be your normal departure config. Flap 2 is the best compromise between performance off the runway, second segment climb and tail clearance. So you'd use flap 2 at places like Funchal, where you want to get off the ground with the maximum tail clearance possible. 1 plus F is best for fuel burn and second segment climb. Mr. Chu, we were talking about that earlier, the RSBN system, I think. It's not something I've looked at, but it'd be interesting to have a look at. Flaps 3 takeoff, Amy. Yeah, it comes up quite frequently. So the reason being, it really depends on what software the operators are using. The 320 doesn't suffer from climb performance issues. Around about Europe especially, there aren't many airports. They operate a 322 where it's performance limited. Okay. So you can either do, with the software options that are available, not just the Airbus software but other commercial offerings, you can either optimize the flex or you can optimize the topple, the takeoff performance limit weight. If you always optimize the flex, there's a reasonable chance that it'll usually do flap 1 departures, because you can have reduced power and still make the climb gradient. When you're optimizing the takeoff weight, it will more likely give you a higher flap setting, because the aircraft has got the performance to climb away at maximum weight with 2 engines running, no problem at all with flap 3. But by optimizing it, by looking for the very highest takeoff performance weight, it'll push you more towards flap 2 and flap 3 than it will flap 1. So it really just depends on the settings either the company or the pilots use on their performance tool, whether or not you get a high flap or a low flap takeoff. But flap 1 plus F would be normal. Flap 2 is fairly common. Flap 3, you'll see it a lot if you optimize takeoff weights and you fly 321s, you'll get a lot more flap a lot more frequently. And the problem is it's producing a theoretical takeoff weight that is 20 tons beyond your maximum takeoff weight. Sometimes it makes very little sense. Has anybody ever seen the performance charts and wondered why you have a performance weight? Let's say on a theoretical aircraft type you've got a maximum takeoff weight of 75 tons and you'll have performance charts up to 80 tons. Do you know why those performance charts are provided in that case? I think a lot of people think it's a mistake why you have a performance figure for a weight that you can't possibly achieve. You have a think about that while I check this calculation. We've got 50 kilometers to go. We're navigating from FFM to Bob, so after Bob it's 276.1, 276.1, 133.7, that's checked on there, and 279 is standing by. Yeah, that's correct, Amy. So Easy would use the Airbus FlySmart, and it will by default optimize your flex. Captain Crash nails it, as you'd expect. Every change to an aircraft configuration can be attributed as a weight penalty. So if you are, for example, missing something like a slat or flap track fairing, the little fairing that goes on the underside of the wing that covers the mechanism, you can legally go flying with it, and how you account for it is a weight penalty. So if your aircraft was at 75 tons, you would have to use performance figures for 77 tons, for example. And that's why you have performance charts beyond the takeoff weight limits on the aircraft. And it's the same for landing. You need to be able to extrapolate those charts, or to use those higher values to allow for any deviation from the normal config. So the next segment is 14.6 to 14.5. I'll move those over just now because I'm not doing anything else with them. 14.6 to 14.5. Yeah, sand patches, you can fly with a lot of things hanging off aircraft. Flap track fairings, not an issue. As long as there's no damage to the remaining structure, you're fine. Most crews would make a public address. If it's something the passengers can see, they'll make a public address. For me, if I'm flying with a bit on the underside of the aircraft that isn't quite right, I will, for a start, not board customers using the back doors, because I don't want passengers walking by the bit of the aircraft that's hanging off on the ground. And I prefer to use the jet bridge rather than steps at the front, so that you just don't expose people to that environment. But that's just trying to minimise the amount of nervous passengers. My mum is terrified of flying. She will not set foot on an aircraft unless she absolutely has to. And I just think that, how would she react to seeing that on an aircraft? I try and mitigate that for anybody else that's nervous of flying. So if you don't see it, you don't know about it, you don't worry about it. If you watch the departure of British Aerospace 146 out of London City with Flybe, they would often give announcements that the aircraft made an odd noise during the climb out, and that's because it made a hoot. When the flaps retracted, there was an aerodynamic noise as the flaps came in, and it sounded like something was falling off for a few seconds. And they would do the PA to that effect. Here is Brussels. Did my correction make any difference at all? Let's see. Come on. Come on, X-Plane. Let me use it. It's there. No? Oh well. Close enough. 2.5 miles, that's fine. Right, and we are counting down 130 kilometres to go. It's on that side there, 134, 132. Yeah, it's pretty close. So we're navigating towards Coxey, he says. Yes, navigating towards Coxey. We're going to start the descent 40 kilometres before Coxey. If you were flying without the NVU calculator and you're flying VOR to VOR, work out your track miles and descend based on that. If you've got a terminal VOR, a VOR on the airport, tune it, look at the distance and descend at the appropriate point. And don't worry about the little turns you do on the arrival. If you've got 90 miles direct line to descend, then descend from 30,000 feet at 90 miles. It really doesn't have to be more complicated than that. Vinny, I took her flying once in a PA-28 because she really wanted to go flying. It was not long after I got my PPL and she wanted to go flying, and we're flying along in this PA-28, and it was one of these kind of late winter, early spring days. It was beautiful. Clear blue skies, not a single bit of wind, no clouds. So the atmosphere was completely and utterly still. You could fly the aircraft hands off for 100 miles and it wouldn't need any adjustment. And we got into the kind of cruise phase, and I was pointing out things on the ground, looking at houses, and my mum said in a very nervous voice, "Why are the wings moving?" I said, "Look, you're going to have to be more specific. When you say moving, do you mean forwards? Because that's kind of how they work." She's like, "No, don't be silly. The little bits on the end of the wings, that they're moving up and down." And I'm like, "You mean the ailerons, the little wings, that they're controlling the roll?" So I demonstrated the roll. She's like, "No, don't do that. Don't roll the aircraft. No, those bits there, they look like they're going to fall off." And she was talking about the static discharge wicks on the trailing edge of the aileron flapping in the breeze, and she thought it was a serious flight safety thing. And from that day onwards, I kind of treat my nervous passengers as if they're that paranoid about the thing falling apart. You just try and do the best you can. You don't want passengers having a panic attack in flight. So if you can explain something to them on the ground, then that's a better way to handle that situation, I think. So we are Brussels to Coxey. After Coxey, 90 miles to go, 90 kilometres to go. Right, let's set up the next point. So 276.1 is what we're using, so the next one is 273.0. I'm going to change the one that isn't lit up. I try and say the same thing every time. I try and repeat the process using the same language so that it eventually sinks in and then it just becomes a natural thing for me. Just repetition basically. 273, 273, distance is 95, Sierra Papa, it's this point here, and I want to set 90.5. I think after Dover, we'll revert to VOR navigation, we'll find our way to Biggin, and then we'll take the aircraft directly into Heathrow. Hopefully that'll work out. 90.5, not that one, this one. There we go. And the course will be 27... what am I doing? 279 is the next course, 287 is the current course, 279. Okay, perfect. Yeah, I don't have any wind set on Sandpatch, but you know, it's not precise. You have to correct it as you go. It is nowhere near as accurate as an INS would be over this short distance, that's for sure. And Doppler systems basically weren't like that. If you've got a short range fitted aircraft, the Doppler system may allow you to cross a 500 nautical mile gap between VORs. It might let you cross, for example, the North Sea if you were going from the UK to Norway or Sweden. But you wouldn't use it transatlantic. That's different. You'd need to do proper navigation. They used to have things called ocean stations, which were ships that would stay in the same position and give you position checks when you called them up. It's frightening, Captain Crash, when you see how bad some people can be, how badly some people are affected by it, and it must be awful for them because if you're in any sort of business, there is going to be a time when you've got to fly by air, and if you want to go on holiday, it's usually easier to fly, and it's just terrible to see. Thanks for joining the stream, Vinny. I will do my very best to butter it into Heathrow, but there's no guarantees. You enjoy the rest of your afternoon there, and no more 35°C photos. It's just terrible. Have a great one. Excellent. So we're going to descend 40 before Coxey, counting down on Coxey, count up on Brussels. I could actually bring them across just now, so 14.5 is the current one and 14.950 for Dover. There we go. And there's 40 miles, 40 kilometers, so I'm going to flick it into, just going to use Mach hold momentarily and I'll bring the power back. I'll set the altitude down, just as a reminder, we'll go down to 7,000 feet roughly at Biggin, so put it on here. So what am I doing? I've been talking and not thinking. Coxey to Dover is the next leg. So really what I want to do is I want to be able to navigate from Dover to Biggin. That's my primary objective now. I'll trust the NVU to get me towards Dover. I then want to get Dover to Biggin. Okay, so what I'm going to do is set the system, the nav system, the VR system up to allow me to do that. Dover to Biggin is course 282. I'm going to put it on the number 1, 282. I also want to know the distances to Biggin. So I'm simply going to use 15.1 on the number 1 radio. Okay, 15.1, and I'm going to switch over to miles so I can help calculate my descent. You see, from Dover to Biggin there's only 94 kilometers. So I'm not really worried about tracking outbound from Dover That's not going to add any real accuracy to the proceedings. I simply want to track inbound to Biggin. So with a big gap between the VORs, navigate outbound from one and inbound to the other. But if they're reasonably closely spaced, just pick the one that's further away and navigate towards that. It'll be an easier, more gentle intercept, and you'll reduce your workload quite dramatically. So 115.1 is on the left hand side. It's set to miles. I want to be at Biggin at 7,000 feet. That gives me 25,000 feet to lose, and I've got 106 miles to do it, so we are well underneath the profile. The whole, while we're talking about people that are nervous about flying, the whole airport environment is just another way to make people anxious. If you're relaxed and you're looking forward to going on a flight, you're looking forward to going on a holiday, you'll put up with some security stress and you'll put up with queuing at the check-in because, you know, you're going on holiday. But if that stuff makes you nervous, if the flying makes you nervous, then the whole airport experience is just going to be horrible. If somebody tells me, or if the cabin crew tell me that they've got a nervous flyer on board, I will go out my way to speak to them and try and reassure them, try and keep them happy, make sure that they are chilled out about everything. I also forget to switch over from Mach to speed hold, and we get an overspeed. So I'll just bring the nose up. Come on, little airplane. There we go. I mean, why can't it change over automatically? It's not difficult. Right, there's kilometre hold now. Yeah, exactly, Ross. Russell, if you imagine that you wouldn't have to get on that plane and then you've got the stresses of the airport, not a nice situation. I should probably fix the pressurization. We're going down to roughly sea level, so that's going to be 760 millimeters. Around she goes. Oh yeah, there's feet there, meters there as well. I'll do is, and we are. There's my cabin. Yeah, I should probably have done that beforehand. Is that meters? Not doing. Oh no, that's the aircraft. 1,000 feet a minute, that's fine. Arc and brake press. Good call. Good spot. It's this one here. Charge up the accumulator. And do we do a check on the brake pressure as well? Probably. Okay. Right, we have got... I've got to think about what I'm doing. So we are tracking inbound towards Dover. Okay, and I want my number 2 system here to be tracking. That's the track Dover to Biggin. So what I'm going to do is I'm going to switch off auto sequencing with one click, and that'll stop it from changing over. Yeah, just have one guy to do it. Your only job, Dimitri, is to change over from Mach to velocity, Mach to indicated. Dimitri's not really a Russian name, is it? It's more of a Greek name, I think. My bad. In the descent, I'll tell Sophia that we're going downhill as well. I'll put the seatbelt signs on. I'll not leave that to the last minute. I'm also going to switch the other side onto miles because I'll forget. And from Biggin, I'm going to use the London. We're going to use 27 right, which is 111.3. So let's just do that just now. 110.3. 110.3. So we are back to miles and miles, Biggin and the ILS. Sandpatch, do you remember what the auto and the manual switches are for here? And do I need to switch it from DME VOR to localizer? I think I do need to switch it to lock for the approach. I can't remember. So whilst we got a little bit of time in the descent as well, this aircraft does something weird with the approach mode. Specifically, if you arm the glide slope, even from a altitude hold mode, it will go up and capture the glide slope. It won't fly level. If you arm the glide slope, it will pitch to find the glide slope. Lock, you don't have to. Well, let's put it back to DME VOR. The way the Tupolev gets round that is if you've got flaps 28, I think, if you've got the second or the third stage of flaps and the gear down, I think you need the gear. In approach mode, it will activate glide slope automatically. If you don't have that, you want to fly a modern decelerating approach, trying to keep the aircraft clean for a bit longer, then you have to arm the glide slope as it intercepts. You have to push the button as it intercepts. I can set the pointers here as well. 270 is probably enough for this. And 270, done. No, that won't work. I didn't want to do that. Sorry, let me undo my mistake there. I want to go from Dover to Biggin on the 282. I've got 282, so I want to have a look at 282 on here momentarily, and I want to have 282 on there. Excellent, that'll work. I say that'll work, that should work. As we're getting very close, if I just bring up the overhead momentarily, move over to the FO side here, and I switch in between gyro and magnetic, you see there's a much smaller movement now because the datums were aligned to the arrival datum. Yeah, go for it, Winston. You'll be able to catch this thing for sure. Right, only 10 kilometers to go. So what I'm going to do is I'm going to close this window. I'm going to do what I did before, switch it to VOR and then steering, and now I've got the VOR on 282, which is the course from Dover to Biggin, 281.5, and it's about, what, 94 kilometers, so about 50 odd miles. Makes sense, there's Biggin on here. Winston is going to fly underneath, doing about 300 knots greater, and then pull up so that you've got a pretend full view of a 727 planform in the windscreen. Maybe not. So I'm quite far underneath the profile just now. That's a good place to be. I've got 12,000 feet to lose. That's 36 miles. I've got 52, and I do need to slow down a little bit. As we come back to 250 knots, I will get quite high on the profile. So it doesn't really do the 3 times table from cruise. You've got to give yourself a good 20-mile margin on that. And I think the 727 is the same. It's got a fair bit of excess thrust. There you go, you see we're a little bit off course, hence why it hasn't picked up directly. But the NVU, we could tell from the NVU that we've actually gone overhead, so it's a reasonable time to just ask it to establish on that VOR now. We'll revert to conventional navigation. And again, this is completely normal. These little deviations are completely normal for this style of navigation. What's maybe unrealistic is I'm trying to condense everything into the right part of the flight for you to process it mentally. You would do things like this further back. So if you were flying a long cross-country, a long cross-ocean leg, you would transition onto conventional navigation as soon as you could receive that VOR and track it inbound. You wouldn't wait until you're right overhead. Okay, I'm trying to do it at the point in the sim where it's obvious what's happening and why you're doing it, if that kind of makes sense. I hope that's coming across. 732, yeah, the 3 times table, it works, but from the cruise altitude leave about 20 miles margin. So you can use it to assess how you go, and you just use you calculate the margin on it on the way down, Amy. So at the moment we've got 9,000 feet to lose, that's 918.27, so I've got 13 miles margin, and that margin value is what's reducing as we go in. So I'm going to leave Biggin on a heading of 340 degrees. I'll just set that on the steering pointer just now. We can actually put the VORs on, that would be useful. Probably how it's supposed to be done. Yeah, that's exactly how everybody really does it, Amy. You don't want to be on the very upper end of the performance of the aircraft. The airline accountants would certainly want you to be as high and as fast as possible, because that's how you minimise your fuel burn, flying the descent high and fast. But it doesn't give you any margin, really. So correcting comfortably onto that. You see, we're tracking, we're not a million miles away from it. We're in the right country. That's really a good start. I always like it when we're in the right country. Cabin is now down at cabin altitude, that's fine. I need to read more about the pressurization on the aircraft. I'm quite lazy with that. Right, so the number 1 side is doing the navigation, and number 2 can go to the landing system now. So I will set that to 270, it's probably not that critical. 270 on there, not that it really should make any difference in this case. Landing system displayed, and his compass doesn't matter. Excellent. Exactly, Russell, as long as you're seeing the nav aid, you're good. Winston is going for the win now. I should probably start slowing down, so I'll just nose up ever so slightly. We should have done this online, Winston. That would have been quite the challenge. Maybe next time, huh? I'm going to learn how to fly Concorde. So those of you in the stream that don't own the Tu-154, what do you think about it? I tend to like steam gauge aircraft because they're good fun. You're 45D, Biggin. You are only 20 miles behind. I'm doing 280 indicated, slowing down. Planet hemisphere. If you're in the right hemisphere, you're doing well. .300 to 5. I'm going to do this the slow way. I don't mind coming second. I'm fine with that. Just out for a nice time. He says, I want to check the slat that it was working. There we go. I just wanted to double check that. Yeah, it's working. I did an electrical video on this aircraft 4 years ago, and I tried to do something this week and it didn't do what it did in the video. I just wanted to make sure it wasn't broken. .300 kilometers an hour? Oh no. So there's 250 knots, I'll go back over to speed hold. I'm glad to hear that, Mr. Che. I feel the same about it. It's an aircraft I've got to be in the right mood to fly. It's not an aircraft that really works for me in a casual flying sort of sense. And I probably do a couple of real sectors with it, and then it's tiring. It is more work in the cruise than other aircraft. But it keeps you thinking, keeps you aware of what you're doing. And mistakes, I just work on the basis mistakes are inevitable with this sort of aircraft, and I don't really overly worry about it. So I've got 3,000 feet to lose, that's 9 miles, my margin is only 6 miles, seems reasonable. Am I getting a DME from the airport? I am, 33 miles, 10,000 feet, that should just about work out. It does a reasonable job of messing up the intercept if you let it as well. You've got to be careful with the intercept. It's alright if you get radar vectors. I may choose to cheat with the map, we'll see. I should be able to go outbound from Biggin till about 8 miles and then turn on to the localizer. As soon as I put it into landing mode, it will fly a 30-degree intercept. You are 15 miles behind, Winston. You're doing good. So I'm below flight level 100. I'll not bother with the landing lights because there's a 400 kilometer limit on the landing lights. I can't remember. There's Biggin Hill, where we took off in the TBM a couple of weeks ago. Central London. Heathrow's out here somewhere. I thought there was a speed limit on the landing lights, Sampatch. It's good fun, Pilsnerish. It is good fun. It's $30 at the moment. Just consider $30 for this aircraft in the current X-plane economic environment. So we're at 8,000 feet, that's about a mile high. I'm going to turn about 2 miles. It is the year of the heavy aircraft, I feel. The bizjets and the heavy aircraft in X-plane this year. I'm really excited about the 742, the Rotate MD-11, because they've typically done good work on their aircraft. Quite keen to see what any do with the 310, but I'm also really looking forward to the Tolis 340-600 because, you know, their Airbus is pretty spot on. Right, here we go. We're going to turn at Biggin. What I'm going to do momentarily, keep saying that, I'm going to swap these frequencies over just to make it more sensible. So there's 15.1 coming up there, and 10.3 on this side here. Reason being is I'm really interested. I'm going to keep the descent going. Thank you, Mr. Alerter. Let's go down to 3,000. So it's the distance from Biggin here that matters. I'm going to need to touch the speed brake. Speed brake's coming out. I'm going to bring the nose up to put it into pitch hold mode. I'm going to start slowing down. And I'm going to flick the landing mode on now. That gets me the landing information. 18 miles to the runway, 6 miles to the turn. I used to say excellent a lot, but you end up sounding like Mr. Burns, and that's not a good thing. Oh, speeds. I need to look at speeds. And I'm going to put the auto thrust on, so let's switch that on. There's me talking about people nervous about flying, and I didn't bother to do the pilot stuff. Right, 6,000 feet, 17 miles. It's coming good. We've got the speed brake out. A little jink to the right, just to square off the base leg a little bit. So at 400 kilometers per hour, I can take the first stage of flaps. Okay, flaps.
Flaps extending. Slots extending. Stabilizer moving.
That's looking better now. Lower the pitch attitude. Speed brakes can go away.
Flaps 15.
Thank you.
Stabilizer -1.5.
And
Slots extended.
8 miles cross track. Can we see it? Yeah, we should be good. So let's push the approach button here, and it's going to turn to intercept. I'll bring the ILS up on the other side as well. 10.3. Quick double check. Should probably put the
Auto throttle enabled.
Yep, all the throttles in. Yeah, it pitches it moves the stabilizer based on the flat position. It's pretty good. It's 180 knots. Can I couple to the glide slope? Is that a valid glide slope? That's a valid glide slope. It's working well. We are below the 28 speed limit, 360. And we'll do the Heathrow thing of 160 knots, which is roughly 300 clicks. Can have the lights on.
Flaps 28.
Well, it was a bit of a scrappy intercept, but we'll let it away with that. Is Winston on approach? Has he just gone flat out? Oh no, what happened? Ah, crashed. I believe it. You would probably have won, Winston. Not having the map and the weird avionics, it pays to be a bit slower in the terminal area. Really. What else do I need to do? There's some other stuff. I should probably just double check that brake is up to pressure. Our auto thrust is in. Yeah, the stab is just a 3 position based on the CG, and it calculates it total. You can trim the elevator, but the stab moves with. You've got elevator trim and stab trim. It's a bit unusual. That would probably help. 270, 270, and we are 10 miles out, 160 knots. That's the altitude alert. That's fine. Most importantly, there's a runway ahead of us, and we've got 2 and 2 on the Pappies, so. I'll do. So the final speed is 260 kilometers, and the final stage flaps can't be taken until we're below 300. So we'll start slowing down at 8 miles. I don't really want to go in too close. At the current config of flaps 28, we can go down to about 270, so there's not really much in it. Put the gear down. That's just the altitude alert, it's not to worry about. Set 260 on there, give or take. In fact, it's quite slow to respond. Let me just nudge it up a little bit.
Flaps extending.
Next stage of flaps.
Stabilizer moving.
We don't need to arm the speed brake on this aircraft.
Flaps 36.
Thank you.
Stabilizer -3.
Flaps full.
Flaps extending. Flaps 45.
We can call it a draw, Winston. It seems like you're doing really well, to be honest. They're very equally matched aircraft. The higher altitude capability, I think this has earlier high altitude capability, would probably give it the edge if you were prepared to fly it flat out. The touchdown, on the other hand, sometimes it's awesome, sometimes you float like crazy, so we'll see how it goes. So you've got the alpha gauge here, which is pretty useful. The X56? No. We are... You know what, I'm going to take the automatics out and do the rest of it. So I'm going to break the auto thrust out just by moving the thrust levers. It's about 80%. So I just move my thrust levers until we get roughly there. I'll leave the auto thrust armed in the event of a missed approach. And again, break the joystick out just by wobbling the joystick, and we'll fly the flight directors. So keeping the alpha gauge in the scan, 6 units of alpha show that we're roughly on speed. Oh, I am using a Cytec Evo 3D thing. So just a joystick built in, a joystick throttle thing. It cost $30 in 2004. It's on its last legs. But there's no joysticks in stock. I was going to buy myself a T1600 set for Christmas. You just can't get them. You can't get any proper joystick at the moment.
1000.
We are stable. Ish. So the flight directors work quite well, but you've got to fly it looking out the window as well. so speed's good, power setting is reasonable, alpha's good, and everything is centralised. I'm going to bring the reversers in at 3 or 5 metres.
500.
Just to help prevent the float. It goes into ground effect and it'll just sit there looking at you. And then we're going to triple check the parking brake once we get on the stand, assuming we don't go around. It is really nice to fly this aircraft. I'm not worried about those pappies because we're in a slightly lower aircraft than they're really designed for initially. That's better.
$50.
10 meters. 5, 3,
reverse
on. 2, 1 meter.
There we go.
Spoilers up.
I'll just leave it in reverse idle. Not this exit, we'll take the next high speed. Squeeze the brakes.
Turn off reverse.
Yeah, done that. And I'm going to go to the next exit, I think.
Turn 63 is on.
That'll do this. I nearly forgot to do that and went onto the grass, so we'll do it nice and slowly. I think we can turn back on this one though, that should work. So yeah, don't forget to switch your steering back to 63 degrees, otherwise your turns won't be very happy.
Remove flaps and landing lights. Turn on taxi lights.
Let me vacate first, I'll do all that stuff. It's just one of those things, Sandpatch. I speak from experience there. It's like, oh, you'll end up in the grass. It's not a hypothetical thing. Let's taxi down this way. Right, let's put those spoilers away. And let's bring the flaps up. Let's bring the taxi lights on. Retract those. Let's take the transponder can go to alt mode. Weather radar can go off. Doppler radar can go off. Pitot heat can go off. Windscreen heat can go off. And what else can we do? We can start the APU.
Flaps and slots are removed. Stabilizer 0.
Bring the APU up. Let's find somewhere to park that isn't too far away. Oh, I'll just kill the autopilot as well. There we go. Right, we shall go to the right and then to the left. I think we're clear on the right. Yeah, same thing, the Wing Viking, very similar. It's also very slow on the steering sometimes. Don't really mind. So we're going to shut down engine 2 on the taxiing as well, once that APU is up and running. Have I got an APU? I do have an APU, so let's put the APU generator on, let's put the number 2 generator off, and let's put the number 2 bleed off, make sure we don't crash. Let's take the number 2 engine off. APU's on. APU, oh my goodness, why did it not start? Thanks, Captain Crash. There he goes. Fortunately we've got 2 others. I thought it was started. You're right, 3 lights is all. No harm done. I don't actually know if you have to wait for the APU before you shut down the number 2. This is why you have flight engineers. Oh, is that what it is? I see, yeah. The TOLUS exerts the same thing on you even when the real aircraft doesn't have that issue. Right, we'll take the taxi lights off. We're about to turn on to stand anyway. Now the APU is there, let's cycle the APU generator on, and let's run the number 2 hydraulic system. Yeah, everything's in the way, isn't it? Everything's a bit awkward. Outside view, lights are off, everything's good. I'm going to park. I want to park here. This looks like a fun parking spot. 209. You see, if Better Pushback could just draw a marshaller here for me, I'd be super happy about that. It doesn't need to be Better Pushback, but Better Pushback knows where everything is. Better Pushback and Better Parking. That's for another open source contributor to do, huh? What are we not going to do? Release the parking brake and roll away. Repeat after me. Check the parking brake. Doesn't it look mean though? This is one mean looking aeroplane. Right, the parking brake's set. No, it's not. The brake is held. Right, so now I'm going to release that joystick button and push that button. Parking brake is set. Yes. All is good. Right, APU is there. We can turn that hydraulic off. We'll turn the other bleeds off. We'll turn the generators off. Make sure Mr. APU is taking current. I don't think he is. Recycle. There we go. Right, we've got internal power. That's done. I think we can shut it down. We've got bleeds and electrics off. Here we go. This one. Nope, this one and this one. Check for it spooling down. We can switch some fuel pumps off. We can switch some automatic fuel systems off. Close the fire valves. Bleeds are off. Switch off the engine indications. Have we stopped? We are stopping. That's good enough for me. The beacon can go off and the transponder goes to standby. I think we can probably get some doors and ladders, ground power, cargo doors, gear blocks. Right, chocks are in, we're safe, everything is good. I forgot to open the windows to equalise the cabin pressure. That's the weirdest thing on the Tupolev, isn't it? There's no ground sensing dump valve, you've got to open the windows. It's bizarre, especially when it comes from a cold country. You'd think you don't want the windows open at that point, surely. But yeah, I always forget that, Mr. Chu. The Project Tupolev used to have a little box there to remind you, didn't it? But there we are, folks. That is the Tupolev 154 with the NVU navigator. Do you know what? I need to switch off the boosters, switch off the autopilot modes in case I decide to go flying again. Set off the calculation and the corrections, and everything else should be roughly where it wants to be. We've got a few minutes before we have to shut it down. It's just gone over to about 2 hours and 50 minutes. Does anybody have any questions about the Tupolev? If you're thinking about buying it, if you have it and you've got any other little bits and pieces you want to know about it, feel free to ask. I'm always happy to talk about this this fun aircraft. I'm just going to put it onto ground power. Make sure we've got voltage. Ground power comes in. EPU comes off. Everything's good. Exactly, Winston. It's got a lot of things to play with. It's got the same systems as a Western aircraft, as I said at the very outset. It's just you can play with them a bit more. You've got manual control over them. Ross, the pressurization, it does a kind of two-stage pressurization. So this is a single knob here that controls your pressurization altitude. On departure, you set it to 650 millimeters of mercury, which translates to be around about 1300 meters. Okay, so on the departure climb out, you saw it.
Ground, starting APU.
We're not.
APU doors are open, starting area is clear.
No, I'm stopping the APU. We're finished with APU, Felis. When we climbed away, you saw it pressurized to 1300 meters. And it held 1300 meters with no cabin climb. As the aircraft climbed, it maintained 1300 meters as the differential pressure built up. And as the differential pressure got to the 0.6 value, which is the second value in here, this one here, then it started just to maintain that differential pressure. So it goes up to a fixed altitude, it maintains it, and then it pressurizes based on this pressure differential. And on the descent, I believe you set it to the field elevation minus a certain amount, and it will start to pressurize straight away as you descend. I'm not 100% sure of the exact scheduling on it, but it hasn't caused any issues so far. With the VOR navigation, I just work on the basis that you use the FO's side for planning and the captain's side for flying. Remember that you can change what the FO is looking at with this switch here. You can change what the captain's looking at by arming the modes. So whenever you're using the captain's side, check the lights here. You can only change the lights by pushing the mode. So if you want to, you can break the autopilot out of roll mode only, and then change it and then re-engage roll mode. But you don't have to do that, you just do it quickly and it doesn't respond. Yep, RMI just kind of free spins around Toto when it's all there. On the overhead, there is, I should probably turn the seatbelt signs off and let the passengers actually stand up. Might be the done thing. On the overhead, everything is basically straightforward. The gyro here, if it's got that warning light, the little AH warning light, you've got to test it with that to clear the warning light. So I tend to make sure that it's all aligned, the compass is aligned, and then quick test on here, and then bring the autopilot flight director back on again, and that way it should come to life. Everything else is really just setting up the system. So you've got the compass, you've got the gyro selectors, you've got the pitot heats down here, GPS is there, VSI, it's all described on here. You just switch them all on. You can make your life easy with the aircraft by simply starting the APU first. If you get the APU running, you can do everything from that point onwards. If you transition from GPU to APU, you've got to be very careful that you don't have, to start the APU. Before you start the APU, you can't have the hydraulic pumps on and you can't have the fuel pumps on because it'll overload the GPU. So minimal load on the GPU and then start the APU is the way to do it, really. The stuff you saw me do here, checking the phases, it doesn't do anything. You don't need to worry about it. Start the engines, flick the generators to connect, and you're good to go. Yeah, pressurization is very similar to standby in the 737. But that's us. I hope you enjoyed this fantastic aircraft. I really hope that Felis does the 747 to at least the same standard, if not a lot better. And what I've seen on the Discord is it's looking better. It's got lots of cool stuff on there. I hope the INS is going to be as much fun as this. Thanks very much for joining me on the stream, everybody. We've done 2 airliner streams in a row, so next week I think we're good. I think I'm good all the way through March and early April for Friday nights, certainly. So we can have a look at some GA aircraft next week. Let me know on the Hot Start Discord, or just in Discord in general, what sort of aircraft you'd like to see. I was thinking about the SF260, maybe another Islander or something. We'll have a look at it. Thanks for joining me. Have a super weekend, everybody. Stay safe, and I hope you'll join me again soon. Thanks to all the people who have joined the stream, who have subscribed in the past few minutes. If I haven't seen you, JS182 and Mick Trying, thanks very much for following the stream. It'll be on video on demand in a few minutes. Thanks very much, folks. Have a good day.